Remember when it felt like a new JavaScript framework was dropping every week? That's how it feels to work with AI right now. Every few months, there's a new, shiny thing that everyone is talking about. At first, MCPs were the future, something that you had to learn. And before most people even caught up with them, everyone moved on to creating skills. The problem is that most developers are learning these technologies using the wrong approach. Imagine you're building a new AI tool. One user wants a CLI, another wants Claude code integration. Someone else wants it to work inside ChatGPT on the web. And now, people expect you to create a skill for your tool as well. Suddenly, you are not building for one environment anymore. You are building for all of them. And that's where things start to get complicated. The question is no longer, should I learn MCPs or should I learn skills? The question becomes, how do I build a tool and make it work everywhere? That's the question I've spent the last few months trying to answer. I've been building, deploying, and experimenting with all of these approaches. And in this tutorial, I'm going to bring them together into what is probably the most complete guide to AI tooling I've seen so far. Not just how to build an MCP server, not just how to create a skill, but how all of these technologies fit together inside a real-world architecture. We'll start by building a traditional CLI tool that a human can invoke directly from the terminal. Then, we'll expose that same capability through a local MCP server, allowing coding agents like Claude Code, OpenCode, and Codex to invoke it through tool calls using the standard input-output protocol. After that, we'll build a remote MCP server and deploy it to the web, making the exact same operation available to web-based AI assistants like ChatGPT.com over HTTP. And finally, we'll create a skill that teaches an agent how to use our tooling automatically, allowing it to invoke our CLI just like a human would. The interesting part isn't the tool we are going to execute. The interesting part is that every one of these adapters will be powered by the exact same shared core. One implementation, one source of truth, multiple adapters. Along the way, you'll learn how to structure a production-ready monorepo, publish reusable NPM packages, distribute skills, deploy MCP servers, and most importantly, build a mental model for how all of these technologies fit together. By the end of this video, you will understand the difference between skills, local MCPs, remote MCPs, and CLIs, when each one should be used, and how they fit together into a single architecture for building AI tools in 2026. Let's get started. This project is going to be a monorepository with 4 different adapters, which all connect to the same shared core, which finally communicates with the Telegram bot API, which essentially allows us to send Telegram messages through the CLI, where a human can invoke it, through a local MCP server, so Claude Code, Codex, OpenCode can invoke it, or through a remote MCP server, which allows any HTTP client to invoke it, like ChatGPT.com or Claude.com, basically any web application. And the last one that we have is a skill. A skill is a specific hybrid between all of these things I've just explained, and they are basically agent instructions which will allow the agent to decide whether it wants to use the CLI, the local MCP server, or the remote MCP server. Let's take a deeper look at the workflow and how it all comes together. The first workflow I want to demonstrate is the CLI adapter. This one is pretty simple. A human runs a CLI with a command like send telegram, uses a shared core to validate the parameters sent in this command, and finally invokes the send message operation, which triggers the external Telegram bot API. And it looks something like this: message kit, Telegram, the chat ID where we want to send a message, and finally the actual message. And you can see how that looks like here. I have a message, hello from the CLI. So now that we know what a CLI tool is to a human, we get a better understanding of what an MCP server is to an agent. I've just demonstrated what a human would do to use a CLI tool to send a message to Telegram. So we would type MessageKit, SendKit, whatever is the name of the CLI tool, and then we would add some arguments, the chat ID and the message. So how exactly do we make an agent do the same? The answer is an MCP server. MCP server is a standardized way for an agent to perform specific operations in form of tool calls. So how do you set up a local MCP server? A local MCP server looks something like this. What I'm showing you right now is the configuration for OpenCode. But for example, you can see that configuration for Claude Code looks very similar. And the same is true for Codex or whatever else you might be using. But the actual MCP is this. So this is what we're going to be developing, not the actual config. The config doesn't mean anything to us. What we have to do is we have to develop an agent-compatible CLI tool. Now let's demonstrate how it works. Once you set up a configuration like this in your project, you will be able to check it out using the MCPs. You can see that I have MessageKit connected in OpenCode, and I also have it connected here in my Claude code. And once you have the configuration set up, you can use natural language to tell your coding agent to invoke an MCP, and you can pass along the arguments using natural language as well. So use MessageKit MCP to send a Telegram message. Use this chat ID and send this message. Let's go ahead and press enter. In a few seconds, you will see it uses the MessageKit Telegram tool with the chat ID and message argument. And in here, there we go. Hello from OpenCode. Now let's go ahead and test out Claude Code. So once again, I have the configuration ready and I'm telling it to do the exact same thing. So it's going to go ahead, it's going to find the MCP. I need to give it permissions, so I'm going to say yes. And here we have another message, hello from Claude Code. The last adapter which we are going to demonstrate and which we are going to build is the remote MCP server. So why would we need this when we already have a perfectly fine local MCP server? We've clearly demonstrated that agents are able to use it. Well, the problem isn't with whether agents can use it or not. The problem is that remote MCP servers and local MCP servers are made for completely different environments. A local MCP server is great if you're going to have a coding agent running on your machine. But what if you wanted to invoke this MCP server on ChatGPT.com or Claude.com? That becomes a problem because none of these websites have this package installed or this configuration set up. That's why we are going to need to develop a remote MCP server and we're going to need to host it somewhere. Once we deploy it and it is available online, we are going to add a custom application. You can see how I've added MessageKit here in my custom apps in ChatGPT. And you can see how the URL is basically a deployment on a railway, which is what we are going to learn how to do. You can see how in here I've embedded the environment key for Telegram and I've added the MCP suffix here as the route. And I've done the same thing here in Claude. Connectors, and here is my custom message kit. And you can see it recognizes the Telegram tool. So let's go ahead and test ChatGPT first. Use MessageKit MCP to send a Telegram message. Let's see what it's going to do. So it's looking for available tools, and you can see I have to confirm that I wanted to send this message. And there we go, message sent successfully. Let's take a look. Hello from ChatGPT.com. And now let's test the same thing for Claude. So I'm going to use MessageKit MCP to send a Telegram message. And you can see once again, it successfully loaded the tool. And let's check it out. Hello from Claude.com. So we've successfully proven that even on a website, we can still communicate with our MCP tool thanks to the remote MCP server. And that is why you need all three adapters. Now, we still have one question left. Why do we exactly need the CLI tool? So far, only a human can use it. Well, this is where it gets interesting thanks to something called skills. So skills are relatively new in comparison to MCP servers. The way skills work is they are basically a set of agent instructions which explain to the agent how a CLI tool might be used. The reason why this is sometimes beneficial in comparison to an MCP server is token usage. Sometimes a combination of skill and the CLI ends up being cheaper for token usage than local MCP or remote MCP servers. So how can a skill replace an MCP? Well, the first step is to make your skill distributable. The way you do this is just by deploying it on GitHub. That's all you have to do. You need to add your skill.md to a public GitHub repository. I'm going to teach you how to do that in this tutorial, as well as how to develop the actual skill file. And once you publish it on your GitHub repository, you will be able to use npx skills add and then simply link your GitHub repository to your skill location. Go ahead and press enter, install it, and your users will be able to install it in this exact way. And then open OpenCode, and what I've done is I've purposely disabled the MessageKit MCP so you don't think that I'm cheating, right? And of course, the same thing works in Claude Code and Codex. I'm just using OpenCode because it's the first one that came to mind. So how would I do a Telegram operation now? Well, I would go inside of my skills and I would find MessageKit skill, and I would tell it chat ID, and then I would tell it message from OpenCode using skill, not MCP. You can see that it loaded that skill. It is now injecting it. And now it's using MessageKit CLI just like a human would use it. And it even added a --JSON so it can read the output and tell us whether it was successful or not. And in here, we can see message from OpenCode using skill, not MCP. So we have successfully sent a Telegram operation using a skill and not a local or remote MCP server. In this tutorial, you're going to learn how to build this entire architecture that we just went through. You're going to learn how to build a CLI tool, a local MCP server, a remote MCP server, and finally a skill that is going to teach the agent how to use the CLI tool or the MCP server, depending on what it has available and what is cheaper for token usage. We're going to learn how to do this in a production-ready monorepository with a shared core so that we only have to develop the actual send message API once and then easily plug and play into any adapter we create. This is, in my opinion, the most complete tutorial on building MCP tools and skills in 2026. So let's get started. In this lesson, we're going to build the command line interface. This is the first flow we've demonstrated, which is triggered by a human, and only later it will also be used by an agent once we learn how to implement a skill that teaches the agent to do so. The CLI is the perfect tool to build first because it holds the foundation of this project, and by having a human run it instead of an agent, it will be that much easier for us to test whether it works correctly and to demonstrate it in general. It's also going to serve as the perfect foundation to build the shared core, which we are only going to have to develop once and then simply adapt to a local MCP server and a remote MCP server later on. Let's go over all the tools that you need to successfully develop this project. The first and foremost, you're going to need Node installed on your machine. I would always recommend having the most up-to-date version, which in this case is 24.16. But I would just recommend not being below 20, as at this point that is pretty deprecated and might cause problems with some modern dev tooling. To check whether you have successfully installed Node on your machine, you can go inside of your terminal and simply run node-v, and that's going to print out your version. So I'm using 22.20, and that is perfectly fine for me to develop this project. If you have a version below this, I would suggest bumping it up. Once you install Node, you're also going to get access to npm and npx. Don't worry about these versions too much, as they are different depending on the operating system that you're using. So I am on Mac OS, so I have these versions, but if you are on Linux or Windows, you might have some different versions. That's perfectly fine. Just make sure that your Node version is higher than 20 or as close to mine as possible. If you have a higher version than mine, that's also perfectly fine. For npm and npx, just make sure that they are actually runnable and not causing any errors when you try to run them. Now, the second thing we're going to need is bun. You might be thinking, how come we need both Node and bun? Well, we're going to use Node as the final runtime of our tools, meaning the end users to whom we are going to distribute our CLI tools, meaning these ones, the CLI, the MCP server, all of that will be run on Node.js because general population most often has Node.js, especially developers. But to make development easier for us, we are going to use bun as the package manager, and we are going to use it as the monorepository workspaces management, because npm, as far as I know, doesn't come with that out of the box. Besides workspaces, monorepo, and package management, bun also comes with a bunch of handy little tools and utils that replace a bunch of other tools we would otherwise have to install separately and learn. So just to make your mind at ease, yes, we are going to be using bun to develop this, but your end user is not going to need to have bun installed on their machine. So only the developers, you and me, are going to use bun to develop this project. So you should have bun available. This is the version I'm using. Now, I'm not entirely sure if these versions are different depending on the operating system, but as long as you actually have bun and you can run this command without any error, you are perfectly fine. Next, we have git. This is pretty self-explanatory. We're going to be using git for version control. Alongside all of these tools, I would also recommend creating an npm account and creating an organization. You don't have to do this right now, but this will be important if you actually want to distribute this project. So if you just want to build it and test it out locally, you can completely skip this step, but later in the project, when we actually learn how to create an npm package anyone can install, you're going to need to be able to install to create an npm account. I'm on a completely free tier, so all of this should be possible for you to do. You don't have to do it now. I'm just telling you in advance. And same is true for your GitHub account. You should have a GitHub account where you can publish the final project, which is going to look something like this, where we are going to host our skill.md, which will later be used by npx skills commands, which I've shown you in the previous demonstration. So if you have these commands, you are ready to get started. Now it's time to create a new project. I'm going to start by creating a new folder, and I'm going to give it a name of SendKit, which is also going to be the name of this project and the name of the commands that we are going to run. Because of that reason, I would recommend using the exact same project name as me, so it's easier to follow along. Once we create that new folder, let's go inside of it and let's go ahead and initialize an empty Git repository inside.
In case you're wondering, why am I calling this project SendKit when all of the previous demonstration was done under the name MessageKit? Well, for a very simple reason. If I type SendKit, just like you, I get an error. But you can see that since I've already developed MessageKit, I have some leftover commands, which might confuse you, or it might cause a problem with me forgetting to implement something and thinking that it works because I can do it, and it turns out I already have the package installed. So because of that, I'm starting with a completely new name, SendKit instead of MessageKit, so we can truly build everything from scratch once again. So once you have initialized an empty Git repository inside, go ahead and open it in your favorite IDE. For this example, I'm going to be using VS Code. Before we install anything, let's go ahead and add a .gitignore file, which is going to ensure that we don't accidentally commit node modules, dist, our environment files, or anything similar. The only exception we are going to make is for the exact .environment.example file, which we can immediately create. So .environment.example will be committed because it is explicitly omitted from gitignore. And inside of .environment.example, let's go ahead and simply prepare Telegram bot token with this exact name. Now let's go ahead and create a new package.json file. And inside, let's go ahead and open an object with the name SendKit workspace, private set to true, and type set to module. And then let's go ahead and add a tsconfig.json with the following compiler options: a target, module, module resolution, strict, types, and skip libcheck set to true. So this exact configuration isn't terribly important, but if you make yours the same as mine, you reduce the chances of having some type problems or compile problems later when we actually start bundling our command line tools. So because of that, I would recommend using the exact same tsconfig as me. Now it's time to set up a monorepo within this project. And thankfully, we're using Bun, which makes it extremely simple to do so. So you can find the documentation on workspaces by going inside of Bun and select the option of Package Manager. And then down here, you can find workspaces and how everything works inside. So the first thing we have to do is we have to define where are we going to keep our workspaces. So let's go ahead and add that right here. So after type module, let's add a comma, and let's go ahead and define workspaces to be under the packages right here and everything that's inside. So I'm going to go ahead and create a new folder called packages. Now inside of packages, let's go ahead and create our CLI tool. And inside, let's go ahead and add another package.json. Let's go ahead and give it a name of SendKit. Let's give it a version of 0.0.0. And for now, let's go ahead and keep it private. Now that we have the CLI package and we have the root package JSON, let's go ahead and run bun install in the root of our app. And you can see that that's going to say one package installed. And if you take a look at bun.lock, it is going to initialize packages CLI. So now we can go ahead and properly use this CLI package as a part of this monorepository. So make sure that you run bun install from the root of your project after you have added the package JSON here. Now let's go ahead and install some dependencies in our CLI package. So I'm going to change directory to packages CLI, and I'm going to do bun add commander. Next, let's go ahead and do bun add -d at types /node. So let's take a look at our package JSON in the CLI folder now. In the dependencies, I now have commander, and in the dev dependencies, I now have types node. Now let's go ahead and create a very simple example of a command line interface that we can actually run. So inside of the CLI folder, create a new folder called source, and inside index.ts file. In here, we're going to import command from commander. we're going to initialize a new program using new command instance. And then to that program, we're going to attach a name, a description, a command called Telegram with a description, send a Telegram message, two arguments, first one being chat ID and the second one being message. And then finally, an asynchronous action, which gives us access to whatever user wrote for the argument of chat ID and the message. We're going to console log the chat ID, console log the message, and then do a process exit. And last, let's go ahead and add program parse asynchronous process.argument v. Go ahead and save that file. Now that we have this very basic command line interface, let's go ahead back inside of the root package.json. And after workspaces, let's go ahead and add scripts. And let's register one script, dev CLI. And let's make it do bun run packages CLI source index.ts and ensure that that path actually exists. So packages CLI source index.ts. So this is one of the reasons Bun is a very useful development toolkit, as usually it isn't this easy to run a TypeScript file without any additional tooling. So it's small things like that in combination with the workspace and the monorepo and everything else that makes Bun really fun to develop with. But again, I repeat, the end result is going to be node compatible, so your users will not need to have Bun. Only the maintainer, the developer, needs Bun to actually run this. So let's go in the root of our project. So make sure you are in the root and simply run bun install, just to make sure that everything is synchronized. Even though we added some packages directly in the CLI package.json, it's always a good idea to run bun install from the root just to refresh the log file. And then let's do bun run dev CLI. You should get an error, but also you should get usage, sendkit, options, command, sendkit tutorial CLI. And here are the options, help, and here are the commands, Telegram with chat ID and message. So now let's go ahead and actually do it. So CLI, Telegram, some random chat ID and some random message. And you can see the response. I can see the chat ID and I can see the message. So we have successfully confirmed that our CLI tool is actually working. We can accept a chat ID and the message argument, and we successfully print it out, and then we exit the process. Beautiful. So now that we know how to parse the arguments from a command line interface, it's time to actually process it with a Telegram bot API. Now we have to obtain the Telegram bot API key. You can do this by creating a Telegram account, and for simplicity's sake, I would recommend downloading the Telegram desktop client if you have access to it, simply so you can do it all from one machine. Once you log in the Telegram desktop client, you're gonna go inside of search here, and you're going to select apps. And in here, search for bot father. So this is the official Telegram bot creator, okay? So I'm gonna go ahead and click create a new bot, and I'm going to call this sendkit. I'm going to leave the about to be empty, and for the actual name, I'm going to call it, so I'm gonna use a prefix CVA as in code with Antonio underscore sendkit underscore bot. So it's important that it ends in underscore bot. And then let's go ahead and hit create bot. In here, you now have the sendkit bot, and you can see the environment key. So this is what I'm going to do now. I'm going to put this on the side, and I'm going to copy environment example. I'm going to paste it, and I'm going to rename it to just be .environment. And then I'm going to copy this token here, and I'm going to paste it here. There we go. Now let's go back into our CLI index.ts and let's modify it so it actually communicates with the Telegram bot which we've just created. So the first thing we have to do is we have to define a Telegram response type. This is later going to be maintained in the core shared package, but since we don't have that just yet, we're going to develop it here in the CLI. And later, we're also going to use Zod to actually parse the response and not just blindly follow this type which we defined. So the Telegram response that we expect will have an OK property, which is a Boolean, an optional result, which is an object with message_ID, which is a number and also optional, and an optional description. So now what we have to do is we have to go back inside of our asynchronous action here, and first thing first, let's check whether we can actually read the process environment Telegram bot token, so this thing that we just populated. So if the token cannot be found, this CLI actually cannot work. Now let's go ahead and also throw an error if the user didn't provide the Telegram chat ID and if user didn't provide a Telegram message text. And now we have to create the actual fetch to the Telegram API. So luckily for us, this is very simple. We simply have to await fetch https API telegram.org/bot and then inject the token /send message. Then add a comma and open the headers. In here, open the config. The method is going to be a post method. The headers will have content type set to application JSON, and the body is going to be stringified object chat_ID, which is mapped to our chat ID, and text mapped to our message argument. So it's very important that you properly spell this chat ID. So we in here, Telegram accepts chat_ID, but since we are working in JavaScript environment, we use camel case, right? So you can see how I define the argument to be chat and then capital I, so chat ID in camel case. So if you try to extract it like this, it wouldn't be a good idea, even though I think it will work simply because the way we extract arguments is by order of their definition, right? So it doesn't really matter what you name them here, I think. I think it's completely order-based, right? So the first argument in here is the first argument you define, and the second argument here is the second argument you define. But still, it's a good idea to make sure all of these are named exactly the same so you don't have any problems. Great. And now we have the response. And once we have the response, we can extract the data from it by doing await response.json, which we wrap in parentheses, so we can cast it as Telegram response type, which we defined above. So as I said, this isn't the cleanest solution because we are purposely casting something without actually parsing whether the result is correct or not. But don't worry, we are going to do that in the next lesson when we implement the actual core and add Zod and schemas and everything. For now, this is perfectly fine. Now let's go ahead and check if the response is not okay. So if response is not okay, or if data is not okay, let's attempt to extract the detail using data.description or fall back to response.status text. And then we simply console error Telegram API request failed with an attempt to get some detail about why it failed. So this is useful to have both for humans but also for agents so they can tell the user what is missing, what went wrong, why did this request fail. And then what we can do, we can extract message ID from data.result $message_ID. Let's go ahead and do a successful console log, send Telegram message to chat ID. And last but not least, let's do if message ID is not undefined, we can also do console log which Telegram message ID was created. So now that we have this functionality implemented, let's go ahead and make sure the file is saved And how about we try running the command once again? So here I am running bun run dev CLI Telegram with some random chat ID. So this is a random number and a random message. Make sure you're doing this from the root of your project. What's going to happen right now? So you can see it's trying to do something and then it fails. Telegram API request has failed, chat not found. So this is an expected error because this number right here is completely unknown to us. So how do we actually find the chat ID? Well, you do that by going inside of your browser and specifically going at this endpoint. So API telegram.org bot and then bot token /get updates. So if you take a look, it is actually the same as this one. So it is this exact URL, but instead of send message, it is get updates. So go ahead and grab your bot token here and simply replace this part with the bot ID. And then you're going to get the full URL. Then go ahead and enter that inside of your browser, so get updates. And once you press enter in here, you can see that you get a response. Now, my results are completely empty, which is expected because I didn't start a chat with this bot anywhere. So now let's go ahead and do that. And then let's refresh this and see if we get any results. So how do you start a chat with your bot? Well, the easiest thing you can do is go once again in your Telegram desktop client, go inside of search, and this time search within your chats right here, and go ahead and type CWA sendkit_bot, and you will be able to find the bot which you have created. So of course, this is different depending on the name that you have given your bot because all of them are unique. So go ahead and select it. And then down here, you're going to see a big start button. So let's go ahead and let's hit start. You can see that that sends a message to that bot conversation. Then once again, refresh this page and now you will get a completely different result. So scroll down until you find the chat property, and here is the chat ID. Now let's go ahead and try sending a message with that chat ID instead. So I'm going to remove this dummy ID here and I'm going to paste this new one and I'm going to call it hello from dev CLI. So we know that this is a development message. And look at that, no error message. And let's take a look down here, send kit, hello from dev CLI. So just like that, we have successfully made it so we can send Telegram messages using our local CLI tool. So obviously what's not possible yet is to run this anywhere on our machine. What I mean by that is we have to specifically run it using a local script in this project. So the distribution part is going to come later. For now, I just want to focus on us building the operation and the logic and the code base, and then later we're going to focus on distribution and how to publish it. But for now, this is what we wanted to achieve. A bun run dev CLI, which accepts Telegram as a command, which accepts two arguments, chat ID and a message. And thanks to the Telegram bot token, which we have stored in the environment key, it can read it and it can access our Telegram API. So yes, one more message remains. How are your users supposed to store Telegram bot token? Don't worry, we are going to have a solution for that as well. At this point, I would recommend staging all of these changes. You can either do that using VS Code or you can do it using the command line. So either git add and then a dot, or you could have pressed the plus button here, which is now a minus button. And then let's just go ahead and commit this. So git commit, and I'm just going to call this feature add CLI. As simple as that. Or you could have entered the message here. That's it. You don't have to publish anything for now. I just want to make sure that you don't have those uncommitted changes, and so that you can safely start the next feature without worrying of accidental loss of everything you have developed so far. In this lesson, we're going to extract the functionality we just developed within our CLI adapter, and we are going to make it reusable so that we don't have to repeat this logic for every subsequent adapter we plan on building. Let me show you how that looks in our diagram. So what's going on right now in our codebase? We've successfully developed the minimal version of the CLI adapter, which is consumed by a human. But right now, the CLI directly communicates with the Telegram using the operation and the definitions we put inside of the CLI package. So if we wanted to start building the local MCP server, we would have to repeat building the entire Telegram bot API functionality, error handling, types, interfaces, everything once again. And then we would have to do it one more time for the remote MCP server. So instead of doing that 3 times, what we are going to do is we're going to go back inside of our CLI tool, and we're going to create a brand new package called shared or SendKit core, in which we are going to define the Telegram message operation once, as well as all the schemas, types, and interfaces we plan on reusing in all other adapters. Let's start by creating a brand new package. So just like we did with CLI, let's go ahead and create a folder called core. Inside, let's go ahead and initialize another package.json. Let's go ahead and open an object, and let's give it the name SendKit-core. Let's give it a version of 0, private set to true for now, because we're not distributing this package yet. And let's go ahead and give it a type of module. Once we've done that, let's go ahead in the root of our app and let's run bun install. What this is going to do is it's going to update the log file by registering the SendKit core. So it's important that we do that before we start adding any dependencies here. Now let's go ahead inside of our packages, and let's go inside of the new core, and let's go ahead and install the Zod package. So now inside of your core package.json, you should have a new Zod dependency. What I like to do just in case is go back to the root and run bun install once again, simply so the log file is successfully refreshed. Now let's go ahead and use this new Zod package to create all of the schemas which we expect with this Telegram operation. So instead of defining the type like this, where we basically hope that it looks something like this, we're going to be able to use Zod to accurately parse and throw errors if the type or the interface is different from what we expect. So what we are going to do is go inside of core, and I'm going to go ahead and create a new source folder, and inside of core I'm going to create schemas.ts. Inside of this file, let's go ahead and import Z from our new package. And let's start by defining the Telegram message input schema. So this is what we expect from the user to provide us with: a chat ID and message. We expect both of those to be a string with a minimum value of 1. In case this minimal value is not satisfied, we go ahead and throw the error which is described in the next parameter. And then let's go ahead and define what we expect from the actual function which is going to invoke the Telegram message, meaning what are the options of this function. So for now, this is kind of unfamiliar to you. What is this bot token? Because if you take a look at the CLI source index, in here you can't really see bot token anywhere. We extract the token directly from the environment file. Well, yes, that's fine. We are still going to use the environment file for now before we implement the actual distribution of this token. But the thing is, we are not going to call process environment within the core operation. So let me show you. In this shared core, this is where we plan on developing the send Telegram message. Shared core doesn't know which environment it is in. it needs to be agnostic. It needs to work for the CLI, it needs to work for the local MCP server, and it needs to work within a remote MCP server. So we cannot make this SendKit core rely on process.environment. Instead, the bot token is going to be transferred via a prop called bot token. So that is why we are defining this, even though we didn't really use it anywhere. Next, let's go ahead and define the schema for the actual Telegram API. So this chat ID and message is what we are going to accept and values that the user is going to give to us. But this one is going to be what we send to Telegram. Right? So we have to write it in this specific way, chat_ID and text, because inside of here, take a look at the fetch method, that is what we expect, right? So right now, if I go ahead and write this, you will see there is no error. Nothing is warning us that we just wrote an incorrect body here. So to prevent that, we're going to create a schema which is going to parse this. So in case we send something like that, 1, 2, 3, it will cause an error because it does not match this solution right here. Now let's go ahead and define the Telegram response schema. So this is where we get rid of this ugly definition here. The reason I call it ugly is because it's technically a code smell. So we wrote this type because we know it's supposed to look like this, but we don't really validate against it. Take a look at this. So all we do is we cast that type here, meaning that this data is guaranteed to technically have the description and have the okay, right? But with Zod and with this schema, we can actually parse it, and Zod can throw an error and say, hey, I don't know what you expect to got back, but it's not this, it's something else. So you might be wondering, when does that exactly happen? Well, imagine you accidentally used a different API, so different endpoint, and then this endpoint returns completely different thing from what we expect here. Why should it have a message ID or the description? So I just changed this endpoint, and as you can see, my code is never going to warn me that something is wrong. It's just going to break in an ugly, uncaught way. So now I'm carefully gonna return this back to send message. Make sure you do that as well in case you've changed it. And that is why we are defining a schema for the response, so we can accurately parse and check against this definition. So Zod is gonna throw a nice error and tell us, hey, I have an error, message ID doesn't exist. I don't know what that is, but whatever endpoint you attempted to parse this result from is not what you expect. And this type of thing is extremely important, especially when building for coding agents. The more accurately you can give them errors, the better can they provide solutions. So we are not doing this just so it's easier for us to develop, but so it's easier for agents to develop as well. And let's go ahead and add this one, which is Telegram message output schema, which is once again what we plan on returning back from the CLI. So okay, chat ID and message ID. So I'm not sure if we really have an example of that. We kind of do. We define message ID. We have chat ID, but we don't really return it back. Oh, we do. So chat ID and message ID. So just another schema so we can carefully keep track of that object as well. So what this is mostly graceful error handling, because we are working with an untyped API endpoint. We don't really know what's going to return from here. So instead of just hoping for the best and using JSON stringify with chat_ID and text because we know that's what it needs to return or accept, we are gonna stop doing that. We're gonna stop hoping for things, and we're gonna start validating things. So if you haven't already, go through this code that I've written here again and carefully check that you didn't misspell any of these values, because if you did, you will get some errors from Zod. So pay special attention to underscores or capitalizations like bot token and chat ID. And the last thing we're going to do is one cool thing you can do with Zod, which is whenever you have a Zod schema, you can easily transform it into a type. So we're going to export 3 types. We're going to export Telegram message input, which is going to use Zod infer type of Telegram message input schema, which is the first one we've defined here. Then we're going to have Telegram message options, which is the second one we defined here. And last, we're going to have Telegram message output schema. So you can see that now when you hover over any of these types, you can see the exact type we expect. So now it's compatible to use within TypeScript, and we can safely use it across our app by exporting these types that we need. So that's it for our schemas file. Now that we've developed the schemas file, let's go ahead and create its neighbor operations.ts. So the first thing we're going to do in the new operations file is we're going to import everything we've just developed in the schema. So Telegram message output, Telegram message options, Telegram send message request, Telegram send message response, and 2 types, Telegram message options and Telegram message output. And now we can develop a brand new function, asynchronous function, send Telegram message. And instead of just casting objects that we are not really sure of, or params or arguments, what we can do now is we can define one argument input and we can set it to be Telegram message options. So what do we expect this function to accept? You can see that when I hover, I can now accept chat ID, message, and bot token. You can see how we didn't have to define this type. Instead, what we did is we've created the Telegram message options schema. So we can use this to validate whether the arguments the user has provided this function or later the agent has provided these functions are correct. So again, the reason we are kind of complicating this, even though I wouldn't really call this complicating it, I would call this quality code. It's not just for humans, it's for agents. Agents need to be told when they're doing something incorrectly to reduce hallucination. So that is how you build high quality MCPs and skills, by validating all the arguments that are passed within functions. So once we know the input, we can also define the output, but I'm going to leave this for later. Instead, I'm going to start by verifying that whatever this input has received is correct by using Telegram message options schema.parse, and then we send the input inside. So this function is going to fail if whoever attempts to use this operation sends invalid input here, which is again very important for agents so they don't hallucinate and so that they know when they did something wrong. And the next thing we can do is we can prepare the request body. So for this one, we use Telegram send message request schema.parse. And in here, we assign chat ID to come from our parsed input chat ID and text to come from the parsed input message. And now that we have this request body safely parsed here, so this is now going to fail if chat ID is invalid, if text is invalid, or if you accidentally misspell this, it's going to break, right? So you are in a much safer position now. And what you can do now is you can repeat that fetch request. So we're gonna go ahead and open this template literals here, and inside we're gonna go ahead and write the send message API once again. So API telegram.org bot, and then inside of here we're going to inject from the parsed input bot token. So we don't have to directly use input.bot token because we want to use it from this one, which is safe, sanitized, so we know it's not injected with anything and it's 100% safe to use. Then let's go ahead and add a comma, and let's go ahead and open the options here. So we're just going to repeat what we did before. We're going to give it a method of post and headers content type application /JSON, which leaves us with body, for which we can just do response.json request body text. So let's go ahead and compare how these functions look. So this is our new fetch function, which we are developing here in the operations in comparison to CLI index.ts. So you can see how in here, we are using this very weird JSON stringify. We have absolutely no validation that chat ID is a string. We just hope that it's a string. And the only thing we do here is we check if it's available or not, right? So not exactly ideal. Now let's go ahead and see what's going to happen with the response. So let's go back in the operations here. So what we're going to do now is we are not going to just blindly cast the Telegram response. Instead, we're going to generate data by going over Telegram send message response schema dot parse await response.json. So now this is going to break if this response here is anything else from this OK result with the message ID and the description. So we are now parsing and counting on the response to return specific items in a much safer way. You can see that when I hover over data, this is guaranteed to exist here. There is no chance that this isn't the correct type because we have validated it with Zod. So it's going to throw errors if it's not that object. So we can now safely count on the response from this API here to have the correct arguments, the correct body, and the correct response, all thanks to Zod, which our agents are going to be very thankful for. So now I'm going to go ahead and throw errors in case the response is not okay, if data is not okay, or if data result is missing. We're going to attempt to get the description, or with a generic message, Telegram message request failed, if we cannot deduct why it has happened. And then in the end, we're going to return Telegram message output schema dot parse OK set to true, chat ID parsed input chat ID, and the message ID is now going to come from data result message ID. And if you try and write something like this, you can see it now shows you an error. Why? Well, because the data is strictly validated. So even if you accidentally do this now, you can see it will remind you, hey, no, this is from Telegram API response and they use snake case. They don't use camel case like we do, right? So this is also useful. This entire Zod thing is very useful if you plan on building this MCP code base with agents, with Claude Code or Open Code or Codex. These types of errors are going to help guide your agent in the right direction. That is why Zod and type safety is so important in the age of AI. Great. So to wrap this all up, what we can do, this is not terribly important, but just to prove that everything works fine, you can see we have one unused type, Telegram message output, which is essentially what this function is supposed to return. So what we can do is we can add a colon, promise, and then Telegram message output. And you can see that there is no errors at all because that's exactly what we return. So that is our operations solved. And now we can safely reuse send Telegram message for all of these adapters. We are now going to plug it back into CLI. Then we're going to develop local MCP server and we're going to plug it in there. And then we're going to do the same thing for the remote MCP server. So just like that, we've created a very powerful core for our project, which is environment agnostic, meaning that it doesn't care where it's in. Is it in a CLI? Is it within an MCP? Or is it within a Hono server hosted somewhere, right? That's what we wanted to achieve. A super type safe, validated core which holds all the operations and everything inside. So how exactly do we now plug in this core package into our existing CLI package? Well, what I would try and do is import send Telegram message from sendkit-core. But you can see we have an error here. So let's see, what did we do wrong? First things first, let's check the name. I can see the name matches, sendkit-core. So that shouldn't be a problem. So let's see what it is. And here it is. We didn't add it to the package JSON of the CLI package. So how do you add a package which is defined and developed locally within a monorepository and doesn't yet exist on NPM, because usually you write the name of the package, like sendkit, and then you write some number. So do we do this? Because our core, sendkit-core would be the name of the package, right? So do we do that? Because the version is 0.0.0? Well, not really, because make sure you're doing this inside of the CLI folder package.json, because this is still going to look within NPM. So what do we do? Well, we use workspace. Workspace, colon, and asterisk, like this. So once you define the version like this, it's not going to search through NPM. Instead, it's going to find the neighbor here. So now let's go in the root and let's do bun install. And now, if you take a look at bun.lock, you will find that sendkit workspace packages CLI now has sendkit core. But it looks like we still have some problems here. So let's go ahead and first things first, try and reload the window to see what's going on. All right, so cannot find module sendkit core or its corresponding type declarations. So what exactly is happening right now? Is our sendkit core ready to be used or not? One interesting thing you can try is you can add a / and all of a sudden it's able to actually go within and find operations. That's very interesting, right? But this isn't the most optimized way to do that. This would technically work, but it would be nicer for us and for all future developers for whom we are making this to be able to just import it like this. So in order to achieve that, we have to go back inside of core, source, and we have to create an index file. Inside of this index file, we are simply going to export everything from schemas and everything from operations. But we are not done yet. We have to go inside of the package.json file here, and then we have to add a property called exports. And we're going to define a .source index.ts. Just like that. Then you can go back inside of your index CLI, and would you look at that? We can now use sendkit core and directly find send telegram message, because we technically export all of the exports from operations. So send telegram message essentially gets defined here. Send telegram message, right? That's what happens. And that's why we end up being able to import it in this way. Now, what I really like to do is just run bun install in the root, just in case the log file is slightly different now. And now that we finally have this here, we can start removing some things from here and simplifying this entire Telegram operation in the CLI. The first thing we can immediately remove is this type Telegram response. We are no longer going to need it because we no longer have to pretend that the response looks like something. We instead know and we validate to make sure it looks like that. So we can completely remove that. Now you might be thinking, why are we doing this validation right here if we also parse the input that is going to be accepted? Well, because of this. Process.exit. So this is a very specific command line interface quit that we are doing, which wouldn't be a good idea to put inside of the core. So technically later we could catch the on error of the parsing of the input and throw process.exit, but for simplicity's sake, let's keep this small layer of validation within the CLI just so it's easier for us to, don't have to do some spaghetti code right now, okay? So I repeat once again, the core needs to be agnostic. It needs to work on the server. It needs to work as a local MCP. It needs to work as a CLI. So I can't just move process.exit, which is a very CLI thing, into core. Because what if core is run on the server? It will shut down the entire server. That isn't a good idea, right? But it needs to shut down the CLI because it's not a server. And now what we can do is we can remove the entire response from here. We can remove the data. We can remove all of this pretty much. In fact, let's remove everything from here and let's just leave this lightweight validation layer. And now we can use the send Telegram message for everything else instead. So we're going to do this within a try and catch method. And first things first, let's go inside of try, and we no longer have to write the API endpoint, which is always prone to errors. We can instead simply await send Telegram message. And you can see that we have very type-safe and strict arguments that we have to pass. So we have to pass the bot token to be the token which we are currently extracting via the environment variable. Then we have to pass the chat ID, which we validate up here, and we have to pass the message, which we validate up here. And then we can hover over the result and you can see the exact structure that we are returning. So this is different from the structure that Telegram is returning because we have returned it once again into an object that we find suitable so that we know everything is okay. So after this successful result, we can console log that the Telegram message has been sent and the Telegram message ID. And in the catch method, we can now also capture errors in a safer way. So let's go ahead and do detail. Let's check if error is an instance of error. And in that case, let's extract error.message. Otherwise, let's simply stringify whatever is the error argument. And let's go and do a console error about why the Telegram API request has failed. And everything else is unchanged. So you can see how much modular and how better this is now when we no longer have to maintain the Telegram operation types and interfaces within the CLI. So the CLI shouldn't need to know what the Telegram output input is. That should be in SendKit core. And same is true for the local MCP server and the remote MCP server. None of them should really bother with having all of that architecture about the Telegram message. They are simply layers of communication. CLI is a layer of communication for a human. Local MCP server is a layer of a communication for a local coding agent. And the remote MCP is a layer of communication for an agent or a remote MCP server. None of them should have Telegram logic written inside. That's why we developed the shared core. So now that we go on to developing the local MCP server, we are not going to have to develop this anymore. We are just going to do await send a Telegram message, and it's up to us to make the agent send us the bot token, the chat ID, and the message. That's all the agent has to do. The agent doesn't have to worry if this API endpoint is misspelled or anything like that. You can see that this logic deserves to be separated from the CLI. There's no point for CLI to maintain this. Brilliant. So what should we do now? Well, we should check if everything works. So let's go ahead and do bun install, and then let's attempt to send a message again. So to remind you about how you get the chat ID, you have to get your Telegram bot token, and then you have to go onto apitelegram.org/bot, and then simply insert your entire token here /get updates. You can see that my result here is basically nothing. So if you want to refresh that, all you have to do is send a message again. So I'm going to send hello once again here. There we go. And let's try and refreshing this. And there we go. Once again, you will be able to find the chat ID. So just inject the chat ID, which you just copied from here. And let me change the message. So hello from dev CLI with shared core. And there we go. Looks successful. Let's confirm that it is hello from dev CLI with shared core. Amazing. So we just did a very big refactor, which is going to save us a ton of time moving forward because we are not going to have to implement anything in the core again. Instead, we're just going to continue developing the local MCP and the remote MCP, which are going to import the core with all of the logic and operations and schemas and types ready to be reused. So what I would suggest is just committing these changes so you can safely go on to the next lesson. So git add, git commit -m feature add, or let's do extract shared core. As simple as that, and then you can see I have no more uncommitted changes here. This isn't really required, but I think it's easier for you if you do some commits so you don't accidentally revert your files. In this lesson, we're going to build the main agent-facing interface, also called an MCP. As I've explained in the beginning, there are two types of MCPs, and we're going to build both of them. The one we're going to build right now is called a local MCP. So let's take a look at the diagram again to remind ourselves how this is going to work. The local MCP server is primarily meant to be consumed by agents, specifically agents which run on your machine. The local MCP server is not deployed anywhere. Instead, it uses a standard input-output transport which can basically run anywhere where it's installed, like on your machine, allowing agents like Codex or Claude Code to use it to discover tools and serve as the primary agent interface. In comparison to a remote MCP server, this is very similar to a local MCP server, and it's built using the same SDK. The only difference is that remote MCP server is deployed somewhere, and then it's connected to another HTTP client like ChatGPT.com or Claude.com, which don't have access to your machine and cannot use a standard input-output transport. And the good news is that in the previous lesson, we've developed a package called SendKit Core, which is basically the home for all of our types, schemas, interfaces, and operations, which means that we don't have to implement this again. All we have to do is develop the actual local MCP server and then just import send a telegram message function. That's it. So you can see how much we've simplified our job by focusing on this one shared core, which we can now reuse across all of our adapters like CLI, local MCP server, and the remote MCP server when we start building it. Now let's go ahead and create the new package. So inside of our packages folder, let's create a new one and let's call it local MCP. Another standard practice might have been calling this standard input-output MCP, or STDIO for short. So that would be calling it by its protocol or transport. But to keep it simple, I'm going to call my local MCP exactly that, local MCP, and then later when I develop the remote MCP, I'm going to call it remote MCP. But if you want to change yours to match the transport that they are using, so STDIO and HTTP transport, feel free to rename them like that. But I think it's simpler to call them local MCP and remote MCP. Now let's go ahead and create package.json. Let's go ahead and open an object. Let's go ahead and give this a name of SendKit MCP, a version of 0, private set to true, and let's set the type to be module. Now let's go ahead and let's run bun install in the root of our app. What that's going to do is it's going to refresh the log file so that it registers packages local MCP under the name SendKit MCP. Now we have to add the Model Context Protocol SDK, which we are going to use to develop the MCP servers. So by Googling Model Context Protocol, you can find the standard for building MCPs, which is developed by Anthropic. You can even see on their blog post that they have open sourced the Model Context Protocol, which once again redirects to this exact package. So looking at the documentation of Model Context Protocol, we can find the TypeScript SDK. And this is where we get into a bit of a hiccup here. So what they currently write here in this big important note is that version 1 remains the recommended version for production use. The reason I say this is a hiccup, because this entire documentation down here is actually documentation for version 2. Which is a bit unfortunate, right? So you have to be careful if you're going to point your agents to this documentation, or if you yourself are just going to try and follow along by installing these packages, which are going to be a bit different from what I'm going to do. So since at the time of me making this tutorial, version 1 still remains the recommended version for production use, that is what I'm going to teach you how to do. So what does that mean for you if you're watching this in the future and it says that from now on version 2 is the default version? Well, the good news is that version 1 will continue to receive bug fixes and security updates for at least 6 months after version 2 ships, to give people time to upgrade. So even if it's been more than 6 months and you've only come across this video, I am quite confident that you can still follow along by just manually installing the exact MCP version that I'm using. And then once you finish the tutorial, try upgrading to version 2. Thankfully, you can use agentic coding to help you with that. The reason I'm telling you to still use version 1 is simply so you don't stray off too far from what I am building. So if you want to look at the actual version 1 API docs, go ahead and click right here. And this is where you will find what we have to install. So I'm going to go ahead and go inside of my packages, local MCP, and I'm going to do bun add model context protocol SDK. And that's going to install version 1.29.0. So for those of you watching in the future, if version 2 has come out and you want to follow with the exact same version as me, you can use the same version with simply pointing it to that version like this. But then again, I don't think it's going to be a problem even if you have version 2 and you have to use version 2. I think they are similar enough. The biggest differences I see is that in here you have to separately install server and client, whereas in here we have SDK, and then from here we're going to import server and client. So I think they've just separated some concerns and maybe slightly changed the API. But I think it's mostly going to be very, very similar for you, regardless of the situation you found yourself. So in here, it also mentions something about Zod. So I quickly want to go here just to read that. So the SDK has the required peer dependency on Zod for schema validation. The SDK internally imports from Zod version 4, but maintains backwards compatibility with projects using Zod version 3 or later. So that's why it also mentions to install Zod. But I think that we don't have to do that simply because in this mono repository, we already have Zod inside as the peer dependency. So I think that this will work just fine even if we don't have Zod. But in case you run into some obvious problems mentioning Zod, you can try going inside of local MCP and running bun add Zod here as well. Now let's go ahead and manually add our core dependency. So sendkit core, add it to the sendkit MCP package JSON with this version, basically the workspace version. And then we need to add -d types node inside of local MCP. And just in case, I'm also going to install Zod. I don't think it's going to hurt, and I just want to make sure that this doesn't break. Great, so we have types node, Zod, sendkit core, and model context protocol. Since I'm using version 1, it's SDK. So now that we have these dependencies added, what I like to do is go back into my root and just run bun install so the entire log file is synchronized. Now let's go ahead inside of the local MCP. Let's create a new folder called source, and inside let's create an index.ts. And now in here, let's go ahead and import MCP server and standard input output server transport. Now, here is where you can see how imports for Model Context Protocol version 1 looks like. So SDK server mcp.js. Then again, SDK server standard input output.js. And looking at their GitHub documentation here, that is about to change in version 2. So the reason I'm even explaining this is just in case some of you come across this video and version 2 becomes the standard and you really want to use version 2, you can see that you have to install this package, Model Context Protocol server, and then you wouldn't have to import from SDK. And I'm not really sure if you would have to import the extension. Perhaps they've also resolved that as well. Yeah, you can see that MCP server in version 2 is imported in a much cleaner way, and STD server transport is also imported in a cleaner way. So in fact, this is a pretty good migration start if you want to use version 2. And you will see that this API and this API is almost exactly the same. So it's mostly going to be changes with the imports and the packages you are installing from version 1 to version 2. Now let's go ahead and establish the MCP server. So I'm going to give this a name of sendkit local and give it the version of 0.0.0. Then I'm just going to create a little helper function here. So in this function, I'm going to define get Telegram bot token, and this is going to read from process environment Telegram bot token. Now, this appears to be reading from our .environment file right here, but that's actually not true. So this is actually going to read from wherever the configuration for the local MCP server is defined, which right now doesn't mean much to you, but it's going to make sense once I purposely go ahead and remove this later when we test it out. So you're going to see that it doesn't actually need an environment file to be run. So if the token doesn't exist, I simply throw an error, Telegram bot token is required, configure it in your MCP client environment. So you can see that I don't instruct the user to create an environment file. I'm telling them that their configuration is wrong. And if there's no error, then we just return the token. So now let's go ahead and actually use this server, which we've defined above, to register a tool. So the tool we are going to register is going to be called Telegram. And now we have to define the options for it. So title is going to be Telegram. Description is going to be send a Telegram message. And the input schema, my apologies, I've forgotten to import it, is going to come from the sendkit core. So we don't have to write this again. We are basically reusing the same Telegram message input schema, which we've used in our CLI function, remember? So let me go ahead and find it. So the send Telegram message here uses that schema, right? So we can now reuse it here for the MCP server as well, so we don't have to define it again. That was the whole point of developing the core. And let's also import from sendkit core the actual send Telegram message here. So we now have the input schema, we have the title, and we have the description. And now we have to develop the actual function that does things. So it's going to be an asynchronous function which accepts the input. And inside of here, let's go ahead and get the result by doing await send Telegram message. Simply spread or pass along the entire input. Why can we do this so safely? We can do this so safely because of the input schema. So there is no chance for this input to be something that send Telegram message doesn't expect, because if this fails, it's not even going to get to this point. That's why it was so important for us to define that core and all of that Zod types. You can see that agents really like using Zod because it's so easy to validate the arguments and say explicit and very specific messages about which arguments are incorrect so the agent can correct themselves. That's why Zod is so great to use. That's why I had that separate lesson of separating everything into a core package, which is then reusable across all of our other packages. What we have to do after we obtain the result, which you can hover over to see what it looks like, so we get the chat ID and the message ID, well, we have to return a standardized object here. So for version 1 of Model Context Protocol, that looks like this, an object with a property content, which is an array, and this is basically a single object inside, type text, and then in here, open backticks, send a Telegram message with this message ID to this chat ID. And then in the second property here, we are just going to return the entire raw result without the structured response message. So this is basically what the agent is going to respond to the user inside of Claude Code or OpenCode or Codex, right? And this is to consume the actual structured content. And that is actually how you write an MCP server. We registered a tool called Telegram, just like we registered a command called the Telegram in the CLI using Commander. That's why I wanted us to first implement the CLI tool so you get the mental map of how this works. It's actually very simple. The same way you build CLI tools is how they've define this main interface for agents called MCPs so they can invoke tools. That's why I think it's the perfect example to do first because it really makes it easier. It makes you understand this in such a better and more structured way. And now we just have to start this server. So in here we have created the server, in here we've registered the tool for this server to use, and now we have to open a transport, and just like you would connect to some database, server.connect to that transport. And that is actually it. That is how you build a local MCP server, and you can see how we didn't have to do a lot thanks to the SendKit core, which handles all of the operational business logic for us. So if you want to, you can take a look at the version 2 here just to see the differences. So new MCP server, I think this is almost identical. Yes, you can see no changes in how you create a new server. When you register a new tool, I think that also looks the same. So register a new tool looks the same. In here we have a title and we have input schema, which we use our input for, asynchronous, and you return content. Yep, this looks exactly the same. So if you're using version 2, the only thing you're gonna have to change are the imports. That's it. Everything else is exactly the same. Beautiful. So we now have a local MCP server, but we are not ready yet. There are still some things we have to do, starting by going back inside of package.json. So right now, this local MCP server actually cannot be imported anywhere. So we have to specify exactly what we export from it. So we export source index.ts. If you remember, that's exactly what we had to do in core package.json, because otherwise you would manually have to find the path towards operations or schemas. So we are making sure that user doesn't have to import MCP and then go to /source index.ts, which is ironically how they've made Model Context Protocol to be imported. We are actually better than Anthropic in this manner. Great, so now that we have that, let's go ahead and register it in our main package.json, and then let's try adding a configuration and running it. Now let's go ahead into the root package.json. Let's go inside of scripts, and let's register a new script, dev local MCP, run packages local MCP source index.ts. So packages, local MCP, source index.ts confirm that it is working. And now let's go ahead and just test whether this works or not. Run dev local MCP, and it should appear as hanging. That's the only thing we expect, because this isn't intended to be run by us. This is intended to be run by agents. But if it is running and appears to be hanging like this, it means it is correct. If it threw an error, that would mean we did something wrong. So how do we test this out? Well, by creating MCP configurations and opening Claude Code or OpenCode. So let's go ahead and try that out. Let's go ahead and open OpenCode or Claude Code, whatever you might be using. The goal is to successfully add configuration for both. So let's check it out. I assume most of you are using Claude, so I'm going to do that first, and then I'm going to do OpenCode. Regardless, if you go ahead and type MCP command in your Claude code, you shouldn't see anything related to SendKit. So I have a bunch of MCPs here. You can see I've disabled all of them. The only one I have connected is from my web platform, which is MessageKit, which you probably don't have, so you can ignore that. Basically, what I'm trying to say is right now I have no MCP servers connected. Same thing in OpenCode. If I open, there are no MCPs connected. So let's go ahead and go in the root of our project and let's create a file .mcp.json. So this is a specific reserved name for Claude code. So in here, go ahead and open MCP servers, register the server under the name SendKit, type standard input output, and then the command is going to be bun, and the arguments will be run dev local MCP. Obviously, later this will be changed to the deployed npm published package, but until we do distribution, this is the only thing we can do. That's why we've registered it here, local MCP, and we've tested it to confirm that it throws no errors. And this is what I was telling you about. This is the environment. So when I told you that in local MCP, the process.environment will be read from a config and not from your .environment, that's what I meant. So for now, let's go ahead inside of .environment and be very careful here, because mcp.json is not put under git ignore. So you might accidentally commit it with your Telegram bot token. So just be very careful, okay? So I'm going to add the Telegram bot token here. Okay, that's the first one I'm going to do. And since I'm already creating these, I'm just going to create another one called opencode.json. So if you don't use OpenCode, you probably don't care about this, so you don't have to. But you can see that in a very similar way, you develop the configuration for OpenCode. So once again, I'm going to copy this and I'm just going to add the token here. Great, so now that we have these two, let's go ahead and restart both of them, OpenCode, Claude, and you can see that it immediately found a new MCP server, and it's telling me to confirm I want to use it, so I'm going to confirm use this MCP server. Let's go over MCP, and let's go ahead and find SendKit, connected one tool. And we can even see the command and the arguments here. We can see the config location. We can click view tools and you can find the tool here, which is Telegram. You can see the tool name. You can see the full name, which was constructed by the Model Context Protocol SDK. Description, send a Telegram message. Parameters, chat ID, and message. So the exact thing that we defined in here when we registered the tool. Here is the description, send a Telegram message. That's exactly what we see here. Here are the parameters, input schema. You can see chat ID and message using Zod. So we are 100% safe with using this MCP. And let me check in OpenCode here. There we go. SendKit successfully connected to OpenCode. So now let's go ahead and send a Telegram message using Claude Code and local SendKit MCP. So once again, if you forgot your chat ID, go ahead and send your bot a message using either Telegram desktop or Telegram mobile. And once you send a message to your bot, go ahead to apitelegram.org/bot, and then go ahead and enter the entire bot token /get updates. So if you don't send your bot a message first, there's a chance the result might be completely empty. If that's the case, just send a message and refresh, and then you will see that latest message you've just sent. So now that you have the chat ID, let's go ahead and try. So use local MCP SendKit to send a Telegram message. And it should actually ask me for the arguments now. So there we go. What Telegram chat ID and message should I send? Let's provide the details here. So I'm going to tell it chat ID, message, hello from OpenCode, local MCP. Let's go ahead, SendKit Telegram, and let's see if it's going to be successful or not. Send a Telegram message, and would you look at that? Hello from OpenCode, local MCP. Now let's go ahead and do the same thing here. So once again, I'm going to tell it use SendKit MCP to send a Telegram message. So it should now load this MCP that we confirmed is connected here. And once again, it should ask us for the chat ID. There we go. And the message is going to be hello from Claude Code, local MCP. Let's go ahead and press enter. And if our configuration is correct, this should work. You can see that Claude Code asks for permissions. So I'm going to say yes to proceed. And there we go. Successfully sent. Let's take a look. Here it is. Hello from Claude Code, local MCP, and hello from OpenCode, local MCP. We have successfully developed our first MCP server, and we have successfully added to OpenCode and MCP.json. So if you want to commit MCP.json and OpenCode.json, I would highly suggest just adding them to your git ignore so you don't accidentally commit these Telegram bot tokens that we've added here. I think there might be a way to actually inject them using the environment file. I'm pretty sure there is. I will try to research for the next lesson. But just in case, put them under git ignore before committing this lesson so you don't accidentally leak your Telegram bot token. Or if you already did it, just refresh your Telegram bot token, right? So no one can use it. So we have successfully developed the local MCP server, which uses the shared core, which uses the external bot API, which is consumed by an agent, Codex, OpenCode, Claude Code. Brilliant, brilliant job. Now, once again, let's go ahead and do git add, git commit with a message, feature add local MCP. That's it. Something to save all of your changes so they aren't accidentally overwritten. Amazing, amazing job. In this lesson, we're going to develop the remote MCP server. Previously, we've developed a local MCP server, which is consumed by agents which run on your machine, like OpenCode and Claude Code. But in order to allow HTTP clients like ChatGPT.com or Claude.com to connect to the same MCP server, we need to create a remote version of that same server. In order to achieve that, we're going to establish a lightweight Hono server, which is going to serve a single endpoint, MCP. It's going to be a POST request with a very simple URL authorization which accepts the bot token users have to configure in their connectors tab, similarly as to how we needed to create a configuration for the local MCP. So what we've built so far is a local MCP server and the CLI adapter. The local MCP server is very similar to what we have to build now. The only difference is the way we are going to distribute that to the agents. The local MCP server uses standard input-output transport, which is fine when it's being consumed by MCP clients which we configure on our machine, so Claude Code, Codex, OpenCode. But if we wanted to use the same MCP server and try to connect it to an HTTP client like chatgpt.com or claude.com, it wouldn't work. Because of that, we have to implement the remote MCP server. The good news is the logic and the entire SDK is exactly the same as in the MCP server. We don't really have to do anything new, just some slight API differences. The biggest difference is going to be that we actually have to create a very lightweight and simple HONO server, which is going to expose a POST request to an MCP endpoint. And we don't have to develop anything in regards to the actual interfaces, types, or operation business logic, because we've already solved that when we implemented the shared core. Instead of developing this within packages like we usually do, we actually have to create a different boundary. And we're going to do that by creating a new folder called apps. And inside of here, we're going to create the remote MCP folder. So why am I developing this within apps and not within packages? Our packages folder holds reusable SendKit units like the CLI, core, and local MCP. But the remote MCP has its own HTTP boundary. It's not a package we are going to install or any of our users are going to install. It is a deployable application. And this boundary that I'm doing isn't my opinionated folder structure. It is an actual practice which is recognized by majority of deployment and cloud services like Railway. So when you have an apps folder, services like Railway recognize that folder and the service you put inside as something deployable. And it doesn't do the same for packages. So that is why we are going to develop the remote MCP within the apps folder. But before we actually do that, we have to go inside of our package.json, and we actually have to add that here in the workspaces. So go inside of apps here, go ahead and add an asterisk and a comma like this. So make sure that inside of your root package.json, you support both apps and packages, because so far we've only had packages here. And now that we've successfully registered the apps folder as the workspace for this monorepository, let's go ahead inside of apps, remote MCP, and let's create a package.json. Let's go ahead and open an object. Let's give it a name of SendKit remote MCP, a version of 0, private true, and type module. Then let's go ahead and install this so it is registered in the log file. In the root of your project, so not within any package or app, in the root, go ahead and run bun install. This is going to recognize the newly registered package and it's going to install it and register it in bun log. So now if you scroll down here, well, somewhere it's getting pretty large, you will be able to find the newly registered, oh, here it is, SendKit remote MCP. Now let's go ahead within our apps, within remote MCP, and let's go ahead and add types node as the development dependency. And let's go ahead and add model context protocol /SDK. So once again, a reminder, this is the package for version 1 of model context protocol. I've explained the difference between versions in the previous lesson. So if you are working with a different version, rewatch that lesson to see the differences in the packages you have to install. And let's go ahead and add HONO here as well, because we are going to need it to establish a server. So if you go inside of remote MCP package.json, you should now see the dev dependencies and you should see the dependencies. And we are missing one more dependency here, and that is our SendKit core, which needs to use the workspace. So once you've done that, go back to the root and run bun install once again so the log file is fully updated. And now we are ready to develop the remote MCP. Inside of remote MCP, let's create a new folder called source, and inside let's create an index.ts file. Let's go ahead and add all the imports which we are going to need. We are going to need to import Hono from Hono. We are going to need to import MCP server from Model Context Protocol SDK server MCP.js, and we are going to need to import a web standard streamable HTTP server transport from SDK server, and then once again that exact transport. So you can see that this is very similar to what we had to do within our local MCP. The difference is in what kind of transport we are importing. So we are once again importing the MCP server, but instead of importing the standard input-output transport, we are now importing the HTTP server transport, because this is going to be an actually deployed service. Besides that, let's import send Telegram message and the Telegram message input schema from our SendKit core. Now let's go ahead and create a function, create server, which accepts bot token as the only argument. Inside of here, we're going to create a new server called SendKit remote and give it a version of 0.0.0. And then once again, let's go ahead and register the tool. We can in fact copy this entire thing here. Let's go ahead and copy it, and then we are going to modify it if it's needed to be modified for the remote server. So you can just paste that entire thing here. Server, register tool. We are registering a tool called Telegram. The title is going to be Telegram. Description, send a Telegram message. Input schema, Telegram message input schema.shape. And the only thing we're going to modify here is in this asynchronous function where we get the input, we don't have to spread the bot token and use the get Telegram bot token. We can simply use the prop which we have. Where does the prop come from? From here. Bot token, right? So this function is not going to be responsible for obtaining the bot token in any way. It's going to be the developer's responsibility to pass it along somehow, all right? So this stays the same, and after that, I'm just verifying that the return content can stay the same, and it most certainly can. So as I said, not much difference in local MCP server and the remote MCP server when it comes to the API and the syntax. It's mostly about this Hono server which we have to run and then call this create server function inside. So let's go ahead and do exactly that. Let's establish a new Hono application and let's go ahead and register a new API endpoint. So we are going to register a post API endpoint which is going to use a bot token inside of the URL. So this is a param, so it's important to add a colon here. If you accidentally remove the colon, then this is no longer dynamic and it's expected to literally be written as bot token. So make sure you put a colon here and then a /MCP. And don't forget, it's a post request. Then let's go ahead inside of here and let's obtain the bot token. So we can do that very easily using Hono, using context request param bot token. Bot token is a string. So if the user goes a post request 123 MCP, bot token is going to be 123. Now we have to create the MCP server using the function we've just developed above and pass along the bot token, which we extract through the URL. Now let's go ahead and create the transport using the web standard streamable HTTP server transport. Very long name. And set the session ID generator to undefined and enable JSON response set to true. And then let's go ahead and simply connect our server to this transport. So very, very similar to how we did it here with the standard input-output server transport. Instead of doing it in the file, we're now doing it within an API endpoint so that it can be connected via some other service. And then let's go ahead and open a try and catch block after the successful connection here. And let's await transport handle request and simply pass along the raw request. And in the finally, make sure to close the server. As simple as that. Now, I would recommend also registering a very simple not found route in which we just return a JSON with an error not found and a 404 status code, simply so we can test the difference between an invalid API route and a correct API route. And now we have to simply decide which port are we going to run the server on. So let's just read from the environment file in case some service like Railway assigns the port, or let's fall back to 3000. And then let's just go ahead and export default the port and fetch app.fetch. And that is the entire code we actually need for the remote MCP server. In order to make this importable and usable, let's go inside of package.json here and let's make sure to register exports, and let's just export source index.ts as the entry point right here. So we are doing that within remote MCP package.json, just like all of our other packages. Let's make sure we have an entry point to source index.ts. Now it's time to actually test this server to confirm whether it's working or not. So let's go inside of our root package.json and let's go inside of scripts. And let's add a new script here called dev remote MCP. And the command it's going to run is bun run apps remote MCP source index.ts and save the file. And just verify that it actually exists, that you didn't misspell it. So apps remote MCP source index.ts. Now let's go ahead and actually run this. So bun run dev remote MCP, and there we go. Started development server HTTP localhost 3000. If you visit the actual server, you should see an error not found. This is expected because the only endpoint that's actually registered is the post request. And if you want to quickly test if your post endpoint is working, go inside of your terminal, make sure you have this remote running, and simply do a curl post request to HTTP localhost 3000, enter whatever you want for the MCP token here, and then /MCP and press enter here. We are still going to get an error, but it is not a 404 error, it is a 406 error. This is actually expected because the only client meant to consume this is an MCP client. So as long as it's not 404, it means everything is okay. So how could we possibly test this on Claude.ai or ChatGPT.com? Well, in practice, usually you would deploy this onto some service, you would get a domain, and then you would use that domain. But there is a way to test this out even before we deploy it. So make sure that you have it running on some port on your machine, like localhost 3000. And now we have to use a tunnel to expose it to the web. You can do this in several ways. There are many services which do this nowadays. I personally like using ngrok. It's something I've been using for ages. There is also local tunnel. I think Cloudflare has some. And keep in mind that this step that I'm doing right now is completely optional, because in a few lessons we are going to deploy this entire thing, and then we're going to properly connect this using our deployed web URL. But in case you can't wait and just want to see whether this works or not, you can go ahead and set up ngrok. That's what I would recommend. Simply download it and you should have ngrok on your machine like this. So once you establish what port you are on, go ahead and do ngrok http 3000, and that should give you this URL right here. It's basically forwarding your HTTP localhost 3000 to an HTTPS domain. The reason I recommend ngrok is because local tunnel often has a whole overriding page which asks for verification that you understand that this is a tunnel, which breaks integration, right? So let's go ahead and try and connect it using this. So I'm going to do it for both ChatGPT and Claude. I think that you should be able to do this on the free tier as well. Go inside of customize connectors, and as long as you don't have any custom connectors, you should always be able to create one. Right? So add a custom connector. I think you can only do this once. So if you already have one, you have to delete it or upgrade to a paid tier. So I'm going to call this sendkit SendKit. And now this is where we enter the URL, but that's not all. We have to authorize it. So how do we authorize? Well, I opted for a very simple URL authorization, which means that I just have to copy my environment token here. I have to add it and then forward MCP. Basically, I have to target this endpoint, which we've just developed, right? Bot token MCP, and I don't have to specify that it's a post request. The MCP client is going to fire a post request here. Perfect. So we actually don't need this advanced settings. We don't have OAuth. We just have a simple URL-based auth token. And just in case you're worried whether this type of URL authentication is a standard or not, here's an example of Firecrawl, which is an MCP server that I personally use a lot, and they actually do the same thing. So they use simple URL API key authentication whenever you create a new MCP server, and they don't do any authentication using OAuth. So this is a pretty regular practice, so you don't have to worry about that. Let's go ahead and click Add right here. And let's go ahead and see whether it has successfully recognized that we have a Telegram tool. So how about we try opening a new chat, and let's try and send a message to our Telegram. So once again, let's obtain our chat ID. In case this is empty for you, the result can be an empty array. Just go ahead and send a test message to your bot, and then refresh this again and find the chat object and find the ID. So I'm gonna go ahead and I'm going to tell Claude to send a Telegram message using SendKit MCP. I'm going to give it chat ID, and I'm going to tell the message to be hello from Claude.ai development, meaning local tunnel or ngrok, right? So I know which message comes from where. So now it's finding tools, and there we go. Claude wants to use the Telegram tool from SendKit MCP, so I'm going to click always allow and message sent. Let's take a look, and here it is, hello from Claude.ai development. Now let's do the same thing onto ChatGPT.com. So in here, you go inside of your profile down here, settings, apps, and go ahead and click create an app. I'm going to call this SendKit. I'm going to select server URL. I'm going to paste that URL we just had in Claude Code. So we use our local tunnel here. Then we use our environment key /MCP. Make sure it's HTTPS. For authentication, set no auth because we have URL-based authentication. And click I understand and want to continue. Let's hit create and see if it is successful. And there we go. You're going to get a prompt, add SendKit to ChatGPT. In here you have some options, whether you want to reference memories and chats to this, it really doesn't matter for us. Let's just hit connect, and then let's go ahead and send a message. So this is what I'm going to say, send a Telegram message using SendKit MCP. This is the chat ID, message hello from ChatGPT.com development. Let's go ahead and see if it will be able to find the MCP. So it's looking for available tools. It's calling a tool. And in a few seconds, I believe, there we go. We have a prompt. Do you want to send this or not? Let's hit allow. And that should be it. Message sent successfully, status delivered. Let's take a look. Hello from ChatGPT.com development. Keep in mind that this is now working simply because we have a tunnel running. So the moment you close the tunnel, all of the MCP servers are actually going to break. So if you take a look at the server now, inside of your apps here, SendKit, and if you refresh, you can see that it fails. And it's also going to fail here if you go inside of customize, connectors, SendKit. Not sure if it has refresh, it has, it's also going to fail. So that is expected, okay? Because this is just for development. Later, when we actually deploy and we have a stable URL, we're going to add new connectors. So the moment you stop your local tunnel, all of the tools are going to break. And every time you start the tunnel again, you're gonna get a different URL. So you're gonna have to update update it if you want to test it out. So just some information for you if you want to show your work to someone. Now let's go ahead and verify all of our changes. I believe this is everything that we needed to do. Beautiful. Package.json, we have the export. Everything seems to be working. Well, we tested everything, so everything should be working. Let's go ahead and do git add, git commit -m feature, add remote MCP, and that is it. All of our changes are now committed. Amazing, amazing job. At this point, we've successfully developed the remote MCP server, but we didn't implement proper authentication for it. What I mean by that is, while we do have a very basic URL token authorization in place, that does not protect our MCP server or our endpoint. The only thing that actually protects is Telegram's third-party API, which means that we need to think of something to prevent spam on our remote MCP server, or to maybe give us an ability to only allow certain organizations, groups, or maybe a company to use our remote MCP server instead of just allowing it to the entire World Wide Web to use it. The ideal solution would be a way for us to create an OAuth client and then use the advanced OAuth settings that connectors or custom apps within Claude and ChatGPT allow us to do, which will then make ChatGPT or Claude prompt the user to sign in instead of just blindly allowing anyone to use our remote MCP server, which will result in our remote MCP server being completely authenticated using the OAuth protocol. What would usually require building login screens, registration screens, consent flows, OAuth client logic, token validation, user management, and months of out-plumbing can all be reduced to a few lines of code with Clerk. Using the link on the screen, you can create a completely free Clerk account, which will give you access to 50,000 retained users for every project you create within Clerk. Besides that, you can create unlimited applications, and all of those applications have their own limit of 50,000 monthly retained users, which aren't just regular signups. They are users who visit at least one day after signing up, meaning that they are actually active within your application. So this is more than generous for a hobby tier. Besides that, you get all of this listed in their hobby tier right here. Once you've created a free Clerk account, go ahead and create a new project. I'm going to give my application a name of SendKit, and you can choose between all of these sign-in options. I'm going to keep it simple, and I'm just going to select email and Google. For now, we are not going to need organizations or billing, so you can just hit Create Application. After you've successfully created your first application, go ahead and select the Express documentation. The reason we're choosing Express is because out of all of the options here, it is closest to what we have, which is a Hono server. And once you scroll down here, you will see two environment variables, Clerk publishable key and Clerk secret key. And you can copy it from here. An alternative is to visit the API keys page, which you can find inside of Configure and then API keys, and once again just select Express because that is the closest to Hono.js. And then simply go ahead and add those two variables to your .environment file. Now let's go ahead inside of our apps and inside of remote MCP. And in here, let's install Clerk Backend and Clerk MCP Tools package. Let's go inside of remote MCP source index.ts and let's import from Clerk Backend Clerk Create Client. Then let's go ahead and extend our Hono by also importing type context. Then let's also import generate Clerk protected resource metadata from Clerk MCP Tools server. Next, let's go ahead and establish the Clerk environment keys. So Clerk publishable key and Clerk secret key. Both of these will be read from our environment variable file. So make sure that you've added clerk publishable key and clerk secret key. I always recommend copying and pasting here. So publishable key goes right here and secret key goes right here. This will ensure that you haven't accidentally misspelled them. Let's go ahead and throw an error if any of those are missing so that we know that something is wrong and that we are missing the correct configuration. So only after we've confirmed that we have the environment keys, we can safely initiate a new clerk client using those keys, the publishable key and the secret key. What we need to do next is register an endpoint within our Hono server, which is going to tell the agent where to find authentication or authorization information. And that's actually the standard defined by Model Context Protocol documentation themselves. So in the initial handshake documentation, you can see that when the MCP client first tries to connect, our server is going to respond with a 401 unauthorized. And we're going to tell the client where to find authorization information. In the example they've provided right here, you can see that they've stored it inside of .well-known path. And that's exactly the path or route that we are going to register and in which we are going to use the generate clerk protected resource metadata so we can just return that and invoke that function within that endpoint. Let's do exactly that. So after we define the new app using Hono, let's go ahead and register well-known OAuth protected resource and then once again bot token and then MCP. In here, let's return a JSON, which very simply invokes the generate clerk protected resource metadata, which has its own object for the properties and passes along the publishable key from clerk, and the resource URL is a new construction, new URL, C request param bot token /MCP C request URL to string. This will ensure that it is passed along in the HTTPS protocol. So that's why we need to reconstruct this URL so that it can be redirected back to it. The biggest problem with this redirect URL is that the protocol, which I've just mentioned a moment ago, often gets changed to HTTP instead of HTTPS. So what we can do to fix this is modify the default fetch function from Hono here. So I'm going to replace this with a new function, which basically gives us access to the raw request parameter, constructs a new URL using request.url, and then changes the URL protocol from the headers with a fallback. So make sure you don't misspell this, and does the same thing to the host using the exact same method. And then in the end, it returns app.fetch, and then it constructs a brand new request. This will ensure that the protocol stays HTTPS and doesn't accidentally get changed to HTTP. If this is confusing you, perhaps once we actually use this and add it to ChatGPT or Claude, you can see the difference by leaving it like this and then adding this, and you will see that one breaks and the other one doesn't. For now, make sure you have this. Now let's go ahead and add some helper functions which are going to help us to authorize this bot token MCP endpoint, which is currently open to the public with only the very simple URL bot token protecting it. Even though it's not protecting the endpoint, it's just protecting the Telegram API. So what I'm going to do here is add a protected resource metadata URL helper, which accepts the context and the bot token. And it very simply returns back a new URL using the well-known OAuth protected resource bot token MCP, which is essentially this API endpoint we've registered right here. Once we've done that, let's go ahead and also register an unauthorized MCP response. So function unauthorized MCP response also accepts the context and the bot token, and it sets the context header to this value here, and the value of the header to be this specific bearer, which uses the function above, protected resource metadata URL, which passes along the context with the bot token. So what this function is going to do is exactly what is described here. We're going to throw 401 unauthorized, and then we're going to use www authenticate header to instruct the client where to find the metadata for OAuth protected resource information. So that is what we are doing. We are creating a reusable function which we can throw, so with a 401 status, with this specific header as instructed in the model context protocol documentation, so that the client gets information about how to properly authenticate. So now that we have these helper functions, let's go ahead back to our bot token MCP post endpoint, and let's go ahead and actually protect it. So what I'm going to do is, just as I've extracted the bot token from the params, I'm going to extract auth header from the headers targeting the authorization key. And then what I'm going to do before I attempt to create the server is check if the auth header starts with a bearer and then an empty white space value here. So I'm going to see if I have this right here. If I don't, I'm just going to throw back unauthorized MCP response and instruct the client to where it needs to go to find the OAuth information. But if I do have that, I'm going to go ahead and open a try and catch block, and I'm going to attempt to extract a request state using await clerk client, which we've defined right here, dot authenticate request c dot request dot raw accepts token OAuth token. And then I'm going to check the response of this request state. And if not is authenticated, I'm once again gonna throw unauthorized MCP response. And finally, in the catch, I'm gonna do the exact same thing. So if anything fails or if anything is missing, I'm redirecting the client to go to the newly registered endpoint, which is well-known OAuth protected resource. So if something goes wrong with authorization, I'm just gonna redirect the client there so it can get the proper information about how to authenticate. Because if this goes wrong, it means it didn't have the correct header. If the request state goes wrong, it means it's not authenticated in the first place. And if this goes wrong, it means something broke in here. And the best thing we can do at the moment is once again redirect to well-known endpoint. Now let's go ahead and run the remote MCP server to which we've just added OAuth authentication. You will have this message from clerk, which means that we have successfully connected clerk to the remote MCP. And now that we have this running on localhost 3000, let's go ahead and create a tunnel, which is going to expose that to an HTTPS URL. Now I want you to prepare Claude.ai, ChatGPT.com, and also go ahead inside of the configure tab within your application. And the first thing we're going to do is go inside of developers and then OAuth applications. And we're not going to create any OAuth applications yet. Before that, we're going to go inside of settings and we're going to enable the following: dynamic client registration. That is going to allow OAuth clients to register themselves dynamically, which is a very cool feature because it means that we don't have to manually add a custom OAuth application for Claude. Instead, it can register itself simply by reading the well-known endpoint. So let's go ahead and see how we can do that. I would highly recommend starting with Claude AI first, because Claude and ChatGPT have some slight differences in how we actually add connectors or custom apps. So using Claude.ai, go inside of customize and connectors. If you have any existing connectors, click on them and then find the three dots button and click remove, because on the free tier you only have one custom connector. So go ahead and add it here. So what I'm going to do is I'm going to call this send kit and then just OAuth so I can differentiate it. And I'm going to go ahead and paste my HTTPS here, and then I'm going to go ahead and add my environment token here. So it's this one. It actually doesn't matter because we're not going to be demonstrating Telegram right now. We're going to be demonstrating OAuth, but this is how the proper URL looks like. So your environment key and then /MCP. If you want to keep it simple, you can even do just any random number like this. But if you actually want to test sending a message, you're going to have to use the proper environment key. And here's the cool thing. I'm not going to add anything in the advanced settings. I'm just going to click add. Let's go ahead and see what happens. So right now it's checking connection. Let's give it a second to see the result. So the checking connection indicator kept spinning indefinitely. So what I did is I just refreshed this and then I clicked on SendKit OAuth again. And then I actually got this message. You are not connected to SendKit OAuth yet. And I have a button to connect. Let's click on it and let's see what happens. If we've implemented this correctly, we should get redirected to Clerk's login page, which is exactly what happened. And more interestingly, if you go back inside of your Clerk's configure and then developers OAuth applications and do a refresh here as well, you will see that Claude has successfully dynamically registered its own OAuth application with all the scopes that it needs, with the consent screen enabled, and it even added a proper redirect URIs. And you can see that thanks to Clerk, we didn't have to implement or build our own login screen, register screen, token verification, email verification, social sign-in, OAuth client, or consent screen. All of that comes built in with Clerk, allowing us to focus on building our app. And would you look at that, we have successfully connected to SendKit OAuth, and you can see that now it can successfully read the available tools, which are Telegram tools. And let's quickly give it a shot. So use SendKit OAuth MCP to send a Telegram message, provide it with a chat ID, and then the message that you want to send. Let's go ahead and see if it will be able to access the tool. It should, now that we have successfully authenticated. There we go. Claude wants to use Telegram from SendKit OAuth. I'm gonna hit always allow. And since we didn't modify any other code regarding the Telegram, which is actually kept separate in the shared core, you can see that this worked successfully. Now let's go ahead and try and do the same thing within ChatGPT. I'm gonna go inside of my settings and then I'm gonna go inside of apps. You can see that I have removed my previous SendKit MCP and I'm gonna create a brand new one. So I'm going to call it SendKit OAuth MCP, so I can differentiate between the other one. And what I can do is I can just go inside of the connectors here, SendKit OAuth, and it gives me a very easy way to copy the URL, or you can just go inside of the terminal and then construct the URL once again. And you can see that ChatGPT immediately recognizes that I have some OAuth settings here. And if you click here, it will actually tell you what it managed to load. And I'm going to show you the problem that happens if you leave it exactly like this. So at first glance, everything appears to be perfectly fine. We have all the scopes that we want. It manages to read all the Clerk endpoints. It has OpenID support. Everything seems to be perfectly fine. But once we create and try to sign in, we're going to hit some problems and I'm going to explain how to fix them. And now that we have this sign in with SendKit OAuth MCP button, let's go ahead and click on it, and there we go. We get redirected back and there is a problem connecting SendKit OAuth MCP. Try again later. And we can actually deduct what the problem is by going inside of configure, developers, and then inside of OAuth applications. As you can see, ChatGPT did manage to create its own dynamic OAuth application, but it's missing some crucial scopes like OpenID. And this is actually a problem that's been documented by other people in the OpenAI developer community as well. But unfortunately, this discussion did not result in a definitive solution. So what I ended up doing instead is created a custom OAuth application myself and gave it the scopes that I want. So let's go ahead and learn how to do that instead. Step 1 is to actually delete the application that ChatGPT attempted to create dynamically for itself. Let's go back inside of custom apps within chatgpt.com. First things first, let's delete the one we attempted to create. Then let's go ahead and click create a new app. Let's go ahead and give it a name. I'm going to copy the URL from here and just paste it. And then once again, I'm going to select OAuth and I'm going to click Advanced OAuth Settings. But this time, I'm going to change from Dynamic Client Registration to User-Defined OAuth Client. And then this will give me the information that I need to add to Clerk, and from Clerk that I need to add here. So starting with the OAuth Client secret, let's go ahead instead of add new OAuth application. I'm going to call it ChatGPT, and I'm going to select all of the scopes. I'm going to set it to public simply because the original ChatGPT dynamic registration set it to public as well. So I assume it needs it to be public. And then I'm going to click add. And in here, I get my secret. So then I can immediately add the secret here. Then I'm going to go back here. And in the redirect URIs, I'm going to copy the callback URL that's provided here. I'm going to paste it and I'm going to click add. And then in here, I finally have the client ID, which I'm going to populate right here. This will automatically select to client secret post. And this is what works for me, so I'm not going to change it. If you've somehow lost the client secret, you could always regenerate it. Make sure that you click save here. So this entire custom OAuth is saved. And then we can leave everything else as is. Once again, click I understand and want to continue. And let's hit create. And let's hope for a successful sign-in this time. All right, let's go ahead and try. Sign in with SendKit OAuth MCP. And there we go. This time, once we've created a custom OAuth with all the scopes that we need, you can see that we can now click allow, which will actually sign in and hopefully now redirect back to ChatGPT. And there we go. SendKit OAuth MCP is installed. And let's do a quick test with the exact same message. Use SendKit OAuth MCP to send a Telegram message to a chat ID and a specific content. And once again, since we didn't actually modify the shared core, there's no reason for this to fail. So let's go ahead and click always allow. And since we are successfully connected, there we go. Message sent successfully. Hello from SendKit OAuth. Let's wrap this chapter up by committing our changes. I'm going to go ahead and call this commit feature add OAuth to remote MCP. There we go. No need to push or anything like that, just something to stage and commit our changes. I just want to add a very quick disclaimer before we finish this chapter. At the moment of me recording this specific lesson, I have actually finished recording the entire tutorial. And I've decided to additionally add this lesson because I think it's very important and it completes the entire knowledge of MCP servers. The reason I'm telling you this because chances are in the next few lessons, I will open my remote MCP server code and you won't see any of the Clerk MCP tools or Clerk backend or the well-known endpoint inside. That doesn't mean that you have missed a chapter where I removed all of that. It just means that I have already finished recording and building the entire tutorial before I decided to come back and teach you how to do this as well. At this point, we've successfully developed the CLI, the local MCP server, the remote MCP server, and the shared core, which means we have everything we need to develop the skill. But the problem right now is that we don't really have any of these adapters published or distributed anywhere. So the skill that we would develop at this moment would only be useful for us locally. And that's not really the point of a skill. The point of a skill is so that it can be distributed and so that any user anywhere in the world can use it. Which means that instead of developing the skill right now, let's go ahead and prepare all of these adapters to properly be distributed and published to NPM, GitHub, or anywhere else we plan to deploy them. Right now, our CLI package works perfectly fine. As you can see, run dev CLI with Telegram command and 2 arguments for chat ID and the message successfully send a Telegram message, which we can confirm right here. But the problem is, if we publish this to NPM, it wouldn't work for anyone. The reason it wouldn't work is because right now, the CLI package is heavily reliant on our environment file, which means that if I go inside of my .environment and temporarily remove the Telegram bot token and try and run this again, you can see that it's going to fail. So this is the experience that any user right now would get if they tried using this package. And that's what we have to fix. So for now, I'm just going to bring this token back so we don't lose it. And then I'm going to go back inside of CLI source index.ts. I'm going to go ahead and I'm going to import home directory from node OS. And I'm going to import directory name and join from node path. And then I'm going to go ahead and import all types of packages from node file system. So that's going to include exist in synchronized version, make directory in synchronized version, read and write file, all synchronized versions. I'm also going to go ahead and install one more package into our CLI package here. So let's go ahead inside of CLI, add Zod. So that's the package which we're going to need. Now let's go back to the root and let's just run install to ensure that log file is updated. Now that we have Zod, let's go ahead and import that as well. So inside of your packages CLI package JSON, you should now have Zod, and now you can go ahead and import Z from Zod. Now let's go ahead and define the configuration path. So this is the path where from now on, each user is going to store their own environment key when they first run this command. So that's going to be the home directory of this user, .config folder, sendkit folder, and then config.json file. Now let's go ahead and create the CLI configuration schema using Zod. So what each CLI configuration needs to have is the Telegram bot token, which simply needs to be at least 1 character. Now that we've defined that, let's go ahead and define a function which is going to be used to write the Telegram bot token from user's argument to user's machine. So let's develop this function. Function write Telegram bot token, which accepts that token. The first thing we have to do is we have to create this configuration path, which we've defined up here. So let's use make directory, directory name, config path, and set recursive to true so that it can create both the config and sendkit if any of those are missing. So that creates the directory. And now we need to write the actual file. So for that, we use write file. We set the configuration path, and then we go ahead and open backtick literals, template literals or backticks, and we go ahead and immediately exit the backticks and do JSON stringify with an object Telegram bot token. We set null and 2 as the arguments, and we end with a new line entry here. And then we open object once again for the properties and we set this specific mode. So this is very specific to Unix operating systems, which basically means this file shouldn't be able to be read by anyone. Now on Windows, it's not exactly as secure, but for this tutorial, it will serve its purpose. So that's how we are going to store the token that the user provides us with. Besides being able to write the token to user's machine, we also need a function to retrieve it. So let's create that function. Get Telegram bot token. Now inside of here, we are first going to throw an error if the path, which we define right here, doesn't even exist, which means this function was never ever run before. So if not exists config path, throw the error. Telegram bot token is required. Please run sendkit init. Then let's go ahead and try and get the configuration. So the configuration, CLI configuration schema.parse, and we are basically using the configuration schema from Zod, and we attempt to parse whatever we currently have written within our config.json. We are using a specific UTF-8 format here, so it's parsable and readable, and if this fails, it technically means that the configuration file that we have stored is corrupted or incorrect. So that's how we are going to use Zod parse. That's why we are using it. We could technically just do, JSON parse here, but then we would blindly allow the config to be anything. You can see the difference. Now it's type of any, but if we do it through parse and you hover over, then we know exactly what's inside. The Telegram bot token, which of course can be optional in a sense that it doesn't have to be written inside. But if it so happens that it is not written, so if this token is not existent, we are gonna go ahead and throw an error once again. Telegram bot token is required. Please run sendkit init. And then let's go ahead and simply return the token otherwise if everything else is correct. Now let's go ahead down here to the program definition and let's go ahead and separate these commands. So I'm going to add a space here and I'm just going to once again call program here. So I have specific initialization with the name and description, and then I have specific initialization of the Telegram command. So nothing really needs changing here, okay? And I'm just going to change the description of this to sendkit CLI backed by sendkit core. So it's a bit more specific about what it does. And now that we've separated these commands, we can go ahead and register a brand new command called init. So this is what users are going to have to run to store their token. That's exactly what we're going to add in the description. Configure the sendkit CLI local settings. And we are going to add a required option, Telegram bot token. The Telegram bot token. So users will have to provide our CLI with their API token. And then inside of this asynchronous action, we receive options and we receive the Telegram bot token. So that's exactly what we need here. And then what we have to do is we have to write Telegram bot token using options Telegram bot token value. And we are going to inform the user which file we've modified. So saved sendkit CLI configuration to config path. So it's going to render exactly what this is for each user depending on their machine, because it's different for every user, of course. Now you might be wondering, how did we get this Telegram bot token camel case name? Because we never really specified it anywhere, we don't really parse it anywhere. How do we know that we're going to have an options object and that Telegram bot token is going to be cased exactly like this with capital letter B and capital letter T? We didn't really specify that anywhere. Well, the answer lies in the Commander documentation. So in the Commander.js documentation here, if we go into options, we can find exactly how multi-word options are normalized. So multi-word options like template engine are normalized to camel case option names, resulting in properties such as program options template engine with capital letter E. So that's how Telegram bot token flag, which we've defined right here, gets transformed into Telegram bot token property we can read from the options. The reason I'm bringing this to your attention is because you can see the obvious difference of how we extract the values in our Telegram command, which doesn't really work by extracting it from an object, but instead it chronologically matches the arguments. So if I called this chat ID 123, it would still have the exact same value, because it doesn't matter what this argument is called, it matters that it's first, and this value is first, this value is second, and this value is second. With required option in Commander, it's different. It's not chronological, it is specifically by the flag name, which gets translated into this. Now that we have developed the init command, let's go back inside of our Telegram command and let's simplify it. So first things first, we are no longer going to check for our token. And we actually no longer need to check for chat ID or message either, because these arguments are actually validated, which is something I didn't know until recently. We can also remove the entire try and catch here, and we don't really have to console log sentences like this. Instead, it would be a better idea if we console logged the JSON stringify result. Looks like we have one stray curly bracket here, so I'm just going to remove it. There we go. And I'm going to indent everything inside. So our action is much simpler now. We get chat ID, message, we get the result, and the console log is a JSON stringify of the result rather than a sentence, send a message to this message ID and this chat ID. The reason we are changing this to be a JSON is for agents, because agents work better with JSON in comparison to some random sentence that we can write. And they also use less tokens. So it's more explicit and more optimized for agents to simply see a JSON output of the result. So now that we have removed the process environment token, how do we actually get the token from here? And thankfully, we can just use our get Telegram bot token function from here. So we purposely used the sync version of all of these, so this isn't asynchronous, so we can directly consume it here. And one more thing I want to do is I want to change the program to be await program parse async, and then I want to go ahead and capture any errors that might appear. And in the catch here, I'm going to console log the error with an attempt to extract the error message, and then I'm manually going to attach the exit code. So this is actually the preferred way of catching errors within Commander. What we had here worked, but this is actually a smoother way of doing it. And just like that, we have completely eliminated the need for our SendKit CLI to depend on the environment token. Let's go ahead and test it out. So if you attempt to run the Telegram command using the chat ID and a message, this time you're going to get a different error. Telegram bot token is required. Run SendKit init. So this is a message we are displaying, but right now it still doesn't exist. So we have to run run-dev CLI init. That's going to tell us that we need to pass a -- Telegram bot token. So let's go ahead and add it here. There we go. Saved SendKit CLI config to users config SendKit config JSON. So it's going to be different depending on the operating system that you are using. Let's go ahead and try and get the value out of it. So users config SendKit config.json, and there we go. Telegram bot token, and you can see that my proper environment file has been stored inside. So if I go ahead and run the Telegram message again, There we go. We have a JSON output that it was successful. OK, true, chat ID, and the message ID. Let's go ahead and check it out. There we go. Hello from dev CLI. And to confirm it works one more time, I'm just going to add some numbers to it. And there we go. So we have successfully adapted our CLI package so that it no longer depends on the environment file. I would still recommend keeping it here just so you don't lose it and so you have quick access to it. But the CLI package itself no longer depends on anyone having that on their machine, meaning it is ready to be distributed. Now let's go ahead and commit our changes, git add dot, and let's do git commit feature, improve the CLI config. There we go. No need to push anything. Let's just make sure our changes are committed so they don't get accidentally overridden. In order to prepare our packages to be published, we need to introduce some kind of type check, linting, and formatting to ensure that builds don't fail and so that we can successfully deploy and publish these packages to NPM, Railway, etc. There's a wide range of tools you can use to format and lint your code. Chances are you've probably encountered a tool called slint, or maybe a formatter called Prettier. You might have also seen a modern one called Biome. The one that I'm choosing for this project is Oxidation Compiler, also known as OXC. I think that in comparison to all of the other ones I've shown, it is the easiest to set up, it is the fastest, the most optimized, and it's simply lightweight and perfect for this project. Additionally, it's also made by Void Zero team, which is the team that currently maintains the Vite project, which you use every time you need to start a new React app. It is also the team behind the bundler, which we are going to use to successfully compile all of the packages that we are using. So because of that, I think that OXC is the perfect linter and formatter to use in this lightweight project of ours. In the root of our project, let's go ahead and install a few development dependencies. This will include the OX compiler formatter, the OX compiler lint, tsdown, TypeScript, and types node. So all of these are development dependencies, and let's add them in the root of our project. So once you go inside of your package JSON, not in any package or app, but in the root, you should now have types node, OX formatter, OX lint, tsdown, and TypeScript. Now let's go ahead and create a configuration file for the formatter. So go ahead and create a .oxfmtrc.json file. And inside, open an object and target the following schema. So inside of your node modules, OX formatter, configuration underscore schema.json. And in the ignore patterns, simply go ahead and add bun.lock. Now let's go ahead and add the configuration for the linter. So again, .oxlintrc.json file. Inside, once again, open an object, target the schema node modules, oxlint, configuration underscore schema.json. For the plugins, set TypeScript, Unicorn, and OXC. Categories, correctness error, suspicious warn. I'm going to leave the rules empty and the environment built-in set to true. That is all the configuration that we need for OXC. To test it out, let's go ahead inside of package.json and let's go inside of our scripts. I'm going to go ahead and add all of these scripts here. So we're going to have a new format script, which will use oxfmt.write, format check, which will have flag check, lint, which will call oxlint and deny warnings, and lint fix, which will use the flag fix. So make sure that you've added these 4 new scripts to the root package.json. Let's go ahead and try running bun-run format :check. This is going to print out all of the files which have some formatting problems in our code base. Now let's go ahead and try running bun-run lint. We have no lint errors, which is great. So we appear to be having some format errors. Keep in mind that in your case, you might have some lint errors, and that's no problem at all. The reason we are doing this now is so that we polish our code before we deploy it or distribute it anywhere. So we always know that it is safe to deploy and won't crash for our users. So how would we fix these issues? Well, one easy way of doing this is simply by calling the format instead of format check. Format check, as you can see, uses the check flag, which simply outputs the problematic files. It doesn't fix them for us. So if we wanted to fix all of them at once, we would just have to run the format instead. Same is true for lint. If we want lint command to fix all of the problematic files, we would run lint fix instead. But there is also a way to do this individually for a single file from your IDE. So I'm gonna go ahead and choose a random file, packages CLI source index.ts. How do I fix the formatting issue from here? The answer is by going inside of the extensions of your IDE and finding OXC. This is obviously if you use Visual Studio Code or Cursor like I do, which share the same marketplace. If you use something else, maybe you won't have this available, so in that case, you're just going to use the fix commands. Once you successfully install these extensions, you can actually see them down here. OXC is loaded, and it has the proper configuration files. If you didn't add the configuration files, it will actually throw an error. So this means everything is fine. But I can still see this X button right here. So I'm gonna click here, and you can see that formatting has an error. There are multiple formatters for TypeScript files. One of them should be configured as the default formatter. So I can click configure here, or I can go ahead and just use format document here. And then it's once again going to prompt me to choose the default formatter. So I'm going to choose OXC. And just like that, you can see that it has modified this file. So I'm going to show you the exact diff changes of this file. No functionality has been modified. You can see semicolons have been added or removed, and some indentation or new lines have been removed. No functionality has been changed. You don't have to worry about that. So now, this CLI index source is not going to appear on subsequent format check. You can see that I no longer have that file listed here as problematic. So I just wanted to show you how you can fix individual files using your IDE. So to not waste any more time, let's go ahead and run bun run format in the root of our app, which is simply going to update all problematic files. And we can do the same with lint. So instead of bun run lint fix if you have any problems at all. So this will automatically modify all files, and you can see that now I have several files which are modified, but none of the functionality has been changed. Only linting, meaning, only formatting and linting, meaning indentation, new lines, line breaks, things like that. Nothing that fundamentally changes the functionality. So I had, 14 files changed. You might have 20, or maybe you had 2 files changed. It doesn't matter, but this is the script that we are going to run before we deploy our projects, so everything is nice and clean. Now that we've solved linting and formatting, let's go ahead and add one more script here in the root called a type check. So this will very simply verify our code against the TS configuration. Now, we know that we don't have any type errors right now because the files would be read within our IDE, but just in case, we can go ahead and do bun run type check. And that is going to go through all of our files and tell us if we have any problems. So these often have to be solved manually because there isn't really a way a script can fix them for you. So they aren't linting issues or formatting issues. They are most likely incorrect code which break TypeScript, which is even more important to fix before distributing and deploying. So if you happen to have some type errors here, which I don't, feel free to visit the source code and then verify my code against yours to see where the problem might appear. And one more thing I want to do is the reason I added types node to dev dependencies in our package JSON is because I've noticed we have some inconsistencies here. So In a package like core, we don't have types node. In the package like CLI, we have types node. In local MCP, we once again have types node. In our app's remote MCP, we once again have types node. So it doesn't make sense that all of them maintain their version of types node individually. I think the reason we started adding this is because the CLI was the only package in the beginning, so we forgot to clean it up. So I think this is a perfect opportunity to do that. Make sure you have one types node installed in the root of your package JSON, and you can then go into individual packages. So local MCP package JSON. Let's go ahead and remove the dev dependency from here. Then let's go inside of core package JSON. In here, we don't have it. If you do, you can remove it now. And inside of CLI, let's go inside of the package JSON here, and let's remove that and the trailing comma. And last one is the remote MCP. So once again, dev dependencies, let's remove that and the trailing comma. So now let's go ahead in the root and do bun install. After you've done this, I would recommend once again running bun run type check, bun run format check, and bun run lint to ensure you have no warnings, no errors, all files match and use the correct format, and nothing is wrong regarding our types. And this is now a perfect checkpoint before we start distributing and publishing our packages. They are now type safe, formatted, and linted. But we already have several changes here, and it's getting kind of hard to define the boundary between this lesson and the publishing lesson. So let's make this easier for us and simply commit all of these files. So I'm going to say feature, add lint, and formatting. There we go. And now we are ready to start distributing our packages. In order to start distributing our packages, we need to create an NPM account. So go ahead and do that first. Once you've created your NPM account, let's go ahead onto our profile and let's create a new organization by clicking on the organizations tab and then add new organization button. In here, the name needs to be unique. Feel free to use the name of your account as it recommends here. Chances are that's not going to be taken. And choose the unlimited public packages, which is a free option, so you don't have to pay anything. Once you've created a new organization with a unique name, you will see it listed here under organizations. And inside, you will see that you have no packages listed. This is, of course, if you created a new organization. If you want to use an existing organization, that's perfectly fine. You can see that in this one, I have a couple of packages, but to make it easier and so that we are all on the same page, I'm going to start from a completely empty organization and we're going to learn how to add public packages here. What you have to do next is connect your command line interface NPM to the NPM account you've just created. So if you type npm who am I, chances are that you're going to get this error, unauthorized. So the next step you have to do is npm login. And once you've successfully logged in, go ahead and try the who am I command once again, and it's going to print out your account name. Now we have to rename all of the packages which we plan to publish on npm to belong under the organization which we've just created. The reason we are doing this is so that there are no name conflicts when you try to publish your package, because chances are someone already took the name SendKit or whatever you've named your project. So with this method, you can publish your packages and name them whatever you want, and they are simply going to be scoped under the organization name you've created. So go inside of your organizations and find your organization name. So for me, that is CWA-dev. The first package we know we are going to publish on NPM is the CLI package. So let's change the name to be CWA-dev/SendKit. So from now on, this is the name of that package. Now let's do the same for the rest of our packages. So our core package is no longer going to be named SendKit core, but instead it's going to have a prefix of our organization name. And same thing is true for the local MCP. instead of SendKit MCP, it's going to be prefixed with our organization scope. So the only packages we've had to do this to are the packages which we plan to deploy or publish on NPM, which means that for our app's remote MCP, we don't have to change anything in regards of the name of the package, because it's not going to be published under any organization, it's just going to be deployed somewhere. But that doesn't mean we are done. Take a look at the dependencies here. It's expecting to use SendKit core from this workspace. But right now, there is no SendKit core because we've renamed it to CLI dev SendKit core. So because of that, go inside of remote MCP package JSON and change the name SendKit core to be the proper rename which we just did. Now let's go over all the other package JSONs which might need this changed. For example, the CLI package and its package JSON. It's also using SendKit core. So let's change that to be the new name. Now let's go ahead and check the local MCP package JSON. Once again, it's using SendKit core. So let's change it to the new name. And then one thing we can do is just do a search for SendKit core and close the log file. There we go. So now we know that we fixed all the package JSON files, but we still need to fix the imports. The imports are not throwing errors right now because we didn't refresh the log file. So I think it will be better if we do that first. So make sure that you have modified all of your package JSONs to no longer use SendKit core, but instead to use the new renamed package. And also make sure that your core is scoped to organization, that your MCP is scoped to organization, and that your CLI is scoped to an organization. So you should no longer have SendKit core anywhere in the package JSONs. In the root of our app, let's go ahead and run bun install. As you can see, this has removed 3 packages and it has installed 3 packages. So now that log file has been refreshed, if you search for SendKit core once again here, and perhaps if we reload the window, this should start to throw us some errors. What I recommend doing as well is also doing a complete delete of your node modules and then run bun install again. And then go inside of your IDE and simply reload window or just restart your IDE. And at that point, you should start seeing errors for any existing SendKit core. So what I'm gonna do now is search for SendKit core within my project here, and I'm gonna fix file by file. So the first one I found is within remote MCP source index.ts. So instead of SendKit core, I'm going to change it to the package we've just created, and I'm going to collapse this for you so you can see the full name. So CLI-dev SendKit core. For you, of course, this organization name is going to be different. And as you can see now, we have no errors. So let's continue. We have 2 more files. So this one is within packages CLI source index.ts. So our CLI index had an incorrect package and now it has the correct one. And let's search for the last one. And this one is located inside of local MCP index.ts. So once again, change the broken package to the new package which works. And I'm going to collapse so you can see the full name in my case. Again, for you, this will be different depending on your organization name. Now that we have our package names in order, let's go ahead and add the actual build or bundle scripts. So the first package we want to do this on is the core package, because every subsequent package of our entirely depends on this. So what are we going to use for bundling TypeScript into distributable JavaScript? So you already saw a sneak peek when we added TS down in the dev dependencies of our root package JSON. So if there's a chance you don't have this, simply go ahead in the root and bun add -d. You can see the exact line of packages when we also added ts down. So this is the one that we care about, and we are now going to use it to bundle. So you can read more about ts down on its website. And fun fact, it's also made by Void Zero, which is the team behind Vite and behind our formatter and linter that we are using. So now that we solved that, let's go inside of core here and let's create a tsconfig.build.json file. So this file is going to extend the root tsconfig. So it's going to target this tsconfig at the root here, and it's going to extend on it with this compiler options. This is what it's going to include. So make sure you have the source folder, otherwise it's not going to work. And it's basically targeting every single TypeScript file within this source folder. And it's going to exclude the dist folder and the node modules. So that's what we need for the tsconfig. And now we also need to add a tsdown.config.ts. So go ahead and import define config from tsdown. Go ahead and set the entry to be source index.ts, and then make sure all of the configuration looks like this. The out extensions are going to be .js for all JavaScript files and .d.ts for all type files. So we are going to have fully type-safe packages this way in a standard industry pattern that is expected whenever someone installs a package. In here, you can see that we explicitly mentioned to never bundle Zod, because Zod is the only dependency that we have for the core. So because of that, we want to make sure that we don't accidentally bundle that inside of our package. So in order to test if our tsdown configuration is working, let's go ahead inside of the package JSON of the core package here, and let's add a scripts build and a very simple command, tsdown. We could technically go ahead and change directory within our package's core and then run the build script, but I think it's easier if we make it so that we can run the build script within the root package. So inside of the root package JSON, after formatting and linting, let's go ahead and add build core, which will do bun run -- filter, and then use the package name which we registered in this package JSON. So double check that your core has that name. Whatever is your name for this package, go ahead and add it here and run build script from that package specifically. So make sure it's named build. Let's go ahead in the root of our project and run bun run build core. And you can see that it successfully bundled our core package using tsdown. So now within our package's core, you should see a dist folder. And inside of here, you should see index.d.ts, which carefully stored all of our types. We also have index.js, which is the compiled JavaScript code, and we have a map file right here. So industry standard production ready bundling here, ready to be distributed. Now let's go ahead and do the same thing for other packages. Let's go ahead and do it for the CLI package next. So inside of CLI, let's add a tsconfig.build.json. Make sure you have the exact same properties inside. And then let's go ahead and add tsdown.config.ts. In here, it is extremely important that your dependencies correctly add the never bundle property. So inside of the CLI package, inside of package JSON, you can see the dependencies: Commander, our SendKit core scoped under your organization, and Zod. So those three dependencies need to be omitted from bundling here. So make sure that those are the exact ones which you add here. I would suggest copying and pasting from dependencies so you don't accidentally misspell them. And now let's go inside of the package JSON of the CLI package. Let's go ahead and add scripts, and let's go ahead and register the build script, which very simply invokes the tsdown. And now that we've registered the build script to the CLI package JSON, let's go to the root package JSON and let's register build CLI script, which is going to filter to the SendKit package because this is what we named our CLI package. We simply call it sendkit. So there is no sendkit CLI, it's just sendkit, and we call its build script. So once again, double check that this name is exactly what you see here in the CLI package JSON right here. And then let's go ahead and try run build CLI. It uses TS down, and there we go. We successfully built that as well. And now let's do the same for the local MCP package. So we start by adding the TS config followed by the TS down file. Inside of the TS down file, make sure you target source index.ts and make sure that inside of the never bundle, you add sendkit core and model context protocol. But let's check if that's all we need to do. For example, we also have Zod here, so let's go ahead and add that as well. So always double check with the actual packages that you have inside. So all of these dependencies need to be omitted here in the never bundle. Now let's go ahead to the package JSON of the local MCP. Let's go ahead and add scripts, build, TS down. And then just like for the previous two, let's go inside of the package JSON here and let's register build local MCP to target our scope sendkit MCP build. And let's go ahead and try it out. So run build, this will be local MCP. And there we go. So all three of our builds are successfully working. At this point, once again, it's a good idea to stage all of your changes, feature, add, build scripts to packages. So all of them are committed, and so you don't lose all of these changes now that we are in a state where we can successfully create a dist folder for every package which we plan on publishing. So we can now adapt the package JSON to read from this generated dist folders and publish that information to NPM. Now that we have the ability to bundle or build our packages, let's go ahead and modify their package JSON manifests so that they are compatible to be published to NPM. Let's start with the core package, as this is the one that all other packages depend on. Inside of the core package JSON, the first thing I'm going to do is after its version, I'm going to add the files property. As you can see by its definition, the files field is an array of files to include in your project when published. So the ones that we are interested in to be distributed to NPM is the dist folder. We don't really care about the source folder. We care about the dist folder because this is where the bundled files are going to live. And since we're about to publish this package, it's no longer going to be private. So let's go ahead and remove that property. Now let's go ahead and add a few more elements here. So before exports, let's go ahead and add main, module, and types. So we are going to target the dist folder and we're going to specify the main field, which is the entry point to our program. We are going to add an ECMAScript module ID, which is once again the primary entry point of our program, but for ECMAScript. And we are going to specify the types property to point to our bundled declaration file. So thanks to TS down, we have all of those. So inside of the dist folder, we have index.d.ts and index.js. Now let's go ahead and slightly modify the exports here. So the entry point will stay the same, but it's going to be an object, and we are going to separate the types and the import. Once again, make sure that you are targeting index.d.ts and index.js for the import. After the exports, we can go ahead and add a whole new property here called publish config and give it an access property of public. And the last thing we have to do is add a few more scripts after the build script. So that's going to be pack::dry, which will run run build, which is essentially TS down, and then it's going to run npm pack --dry run. And we're going to add a pre-publish only, which is a reserved file name. As you can see the definition here, run this before the package is prepared and packed, only on npm publish. So this is a reserved name, so you have to call it exactly this. So before we publish to npm, we are going to make sure that we do bun run build and save this file. Now, once again, so we don't have to enter this package every time we want to build, pack, or publish, let's go ahead inside of package.json in our root file. And after the development scripts, let's go ahead and add release pack core, which will run bun run -- filter and then the name of our core package and simply invoke pack dry. Okay? So make sure that this name right here, cwa-dev /sendkit core, is exactly what you have in the core package JSON here. So that's exactly what I have here. So feel free to copy it and then just paste it here. Okay, make sure you also have this script, pack::dry. So this is the exact script which we've added right here, which runs the build and npm pack. So what I can do now is from the root of my app here, I can bun run release pack core, which is going to run which is going to build using ts down, and then it's going to do npm pack -- dry run. Now let's go inside of this build and npm packed package. So inside of our packages core, and let's go ahead and do npm publish -- access public. So once again, it's going to run build, and now we have to authorize our npm account. So let's do that. And once you've authorized, you will see a successful output here of a new package under your organization with the name sendkit core and the version 0.0.0. And of course, if you now go inside of your new organization here, you will find this published package sendkit core with version 0.0.0. So now that we've published the core package, let's go ahead and publish the CLI package. Let's go inside of the CLI package JSON. Let's go ahead and remove the private flag. Let's go ahead and add the files property to once again be this. Then let's go ahead and once again, after the type module, add our main module and the types all to read from the dist folder. And let's go ahead and modify our exports. So I'm going to add it right here. It looks like we didn't have it before, so make sure you have it now. Exports to separately import the types and the actual entry point. So inside of your dist here, make sure you have index.d.ts and index.js. Besides that, let's go ahead and also define the publish config and set it to access public. And let's go ahead and add two scripts besides build here, pack dry and pre-publish only bun run build. But we are not done yet. So let's take a look at what this is. This is a CLI package, which means that users are going to install it on their machines with an intent to run it in a binary. So they will probably want to do something like sendkit. So how exactly do we register what name gets installed once the user does npm install -g, and I assume it's going to be the name of my organization /sendkit, right? So how do we know that from this installation point, they get this as the command? There is a property for that as well, and it's called a bin. So inside of the bin, go ahead and give it the name of the command which you wish to be executed, so sendkit, and make it target the entry point like this. So once the user installed this, the sendkit is going to be the name of the actual command. So if you change this to sendkit123, in that case, it's going to be sendkit123 once installed. There is one more thing we have to do before we establish the CLI package as something executable, and that is by going inside of source index.ts, and at the top of the file, very important, before anything, you need to add a shebang. So a shebang is basically an instruction which tells your computer what program should run this file. So we are going to specify for this to be Node. User needs to have Node installed on their machine if they wish to successfully run our sendkit command. So make sure you have that and save the file. Now you might be thinking, once we actually publish this to npm, what will this dependency resolve to? Because right now it's written as workspace, which basically means for our local development, simply use this folder right here. But when we publish this on npm, it's going to be a little bit different, won't it? So should we explicitly write our core version here, which we've just published on npm? Or is there a way that we can keep the local version for our development purposes, and every time we do npm pack and npm publish, somehow magically resolve this to whatever is the latest version? Well, there actually is a way we can do that. And that is by not using npm pack and npm publish, but instead using bun pm pack and bun publish. The reason we need to use bun for this is because we are already within bun as the monorepository. So in order to use its monorepository quirks, we have to use bun dev tooling for this. So let's go back inside of packages CLI package.json. And to ensure that this workspace always resolves to the latest published version of that package, because we just published sendkit core, and so that we don't have to manually change this to 0.0.0, which complicates whenever we want to test something locally here, right? Let's go ahead and change this script pack dry to not be npm pack, but instead bun pm pack. You can find the documentation for bun pm on their website under the package manager. So bun pm is basically package manager utilities, and it offers the pack command, which is the same as npm pack. So it even has the exact same option here, -- dry run. So I would recommend actually changing the same thing in core package.json right here. So change this from npm pack to bun pm pack. I purposely didn't want to do this for core because I wanted to simplify it and just say we're using npm, let's use the npm command to publish it. Bun is fully compatible with npm, and since we are using a monorepository, it's actually quite handy for us to use bun dev tooling. It doesn't make too much sense to use it in sendkit core because sendkit core doesn't depend on anything besides Zod. But the moment we try to publish a CLI package, which depends on the core package, we run into a problem because this workspace alias right here means nothing to npm. If you try to do npm pack and npm publish, I'm pretty sure it would throw an error here because it has no idea what version is this, where am I reading this from? Right? So npm isn't aware of the bun workspace within which we are working. So for the pack dry, just make sure you're using bun pm pack -- dry run here in the CLI and also in the core right here. And now let's go ahead and register all of these scripts we've just made for the CLI package into the root package.json right here. So right after release pack core, let's go ahead and add release pack CLI, bun run filter, CWA-dev sendkit pack dry, which is now going to use the bun variant. So in the root of your project, let's go ahead and do bun run release pack CLI, and let's see the output. As you can see, we have successfully bundled it using ts down, and then we run bun pm pack dry run, which has successfully created the tarball and simulated that it correctly works. So once we've done that, let's go ahead and go within our packages CLI, and instead of doing npm publish, so this would be the usual, let's go ahead and change this to be bun publish. And as you can see, it's doing the exact same thing. It's building it, and then it's asking us to authenticate with npm. So regardless of the fact that we just used bun publish, bun doesn't have its package registry. It's using the npm registry. So it's the exact same process, but the difference is that it resolved all of those internal aliases for versions within our monorepo and its packages. So go ahead and authenticate. And after authentication, you will see a successful output of a brand new package being registered on npm called SendKit with a version 0.0.0. And if you go within your organization, you will find that brand new package. And inside of here, you will find 3 dependencies: Zod, Commander, and our previously published package SendKit core, meaning that it correctly resolved the version of this deployed published package. You can even go inside of SendKit core and click on dependents, and even though this doesn't immediately resolve, once you actually click on the number here, it will show you that there is one dependent on SendKit core package called SendKit. Now let's go ahead and test if the package is actually working. So I'm going into the root of my entire machine here, and I'm going to go ahead and install CWA SendKit globally. And let's see what happens once I type in SendKit. There we go. We have successfully installed SendKit globally, and we can now use it outside of this project. So now SendKit init is going to store the Telegram bot token somewhere else. SendKit Telegram is going to send the message. So we have successfully published our CLI package, and as you can see, SendKit binary is registered on this user's machine running Node. Now let's go ahead and publish the last package, which is local MCP. So inside of its package JSON right here, let's remove the private flag. Let's go ahead and add a bin. So once again, this is going to be used by MCP agents in form of a binary executable. So we need to register the name, which is SendKit-MCP, and make it point to index.js within the dist folder. Make sure you register the dist folder under the files property. Now let's go ahead and add the usual main, module, and types, all coming from the dist. Now let's go ahead and modify our exports property to change the entry point to separately aim for the types and for the import. Then let's go ahead and add publish config access set to public. And then let's go ahead and add our scripts here. So pack dry and pre-publish only, and let's make sure that in the pack dry we're actually using bun pm pack --dry run. So this version right here, SendKit core, properly resolves. And now let's go ahead and register its script. So I'm gonna go ahead inside of the package JSON here. We can duplicate this, and this will be called local MCP. And it's going to call SendKit MCP. So perhaps the name of this can be MCP in that case. Actually, it might be better if this was called local MCP, so that every time we run this script, we are very explicit about what we are doing. Because this semantic right here, release, pack, and then the name of the package, could very well later be for the remote MCP. And since we already do dev local MCP, build local MCP, let's also do release pack local MCP, regardless of the fact that the name is SendKit MCP. So the reason the name here doesn't have local inside is because it doesn't need to. Local and remote are simply aliases for us, the developers, to understand the differences between this folder right here and this folder right here. So let's go ahead and do bun run release pack local MCP, and then let's go inside of our packages, local MCP, and inside of here, bun publish access public. Once again, let's authorize and let's see this package published. And just like that, we now have SendKit MCP in our organization under packages. You can see again 3 dependencies, one of them SendKit core, meaning we've once again successfully resolved the published version of SendKit core package. And we can now try installing SendKit MCP once again, even though it won't really be used like that. The way it's going to be used is within this mcp.json and opencode.json. So perhaps I'd rather show you how to properly write this configuration, not by running the local development script, but instead by running the published package. The only thing we have to change is the command right here. So instead of run dev local MCP, let's go ahead and use npx-y, and let's go ahead and point to our newly published package. And for the Claude code configuration, change the command here to be npx, and then go ahead and change the arguments here to be -y, and then once again your published package. So those are the two configs we have: the MCP, the local MCP for Claude code, and the local MCP for OpenCode. Both of them are now using the published package. Let's try and test all of these published packages to confirm that they are still working. So I'm gonna go ahead and do sendkit init --telegram -bot -token, and then inside I'm going to store my token. Once I store my token, you can see the configuration here that it saved the config. Chances are this config already existed because it's the exact same one that we do during development. Now I'm gonna go ahead and do sendkit telegram, and I'm going to add the chat ID and the message hello from CLI deployed on npm. And let's check it out. Here it is. Hello from CLI deployed on npm. So our published sendkit package officially works, and whoever downloads it and installs it on their machine can do these two steps and successfully send Telegram messages to their bot. Now let's go ahead and try OpenCode and Claude Code. Make sure you're running them inside of your project because you still need the configuration for it. So it no longer depends on local MCP package here, but it still depends on the configuration which we wrote here. So if you truly want to test this outside of this project to confirm that it works, just open a new folder and add .mcp.json with this exact values inside, or opencode.json with this exact values inside. For simplicity's sake, I'm just going to be in the same folder. So let's go ahead and do Claude, and let's go ahead and do OpenCode. So as you can see, it immediately recognized a new MCP server here because we updated it. So I'm going to confirm that we can use that here. And it looks like we've hit a problem. Right here, I can see it says one setup issue MCP. So when I go into my MCPs, I can see that sendkit has failed. And even if I try reconnecting, it still fails. And it also fails within OpenCode. Sendkit failed. So what did we do wrong? And how do we debug this? The first thing that I did is actually went ahead and run the package which I wrote in the configuration. So this is the one, sendkit MCP. And look at that. It actually fails. It says command not found. What is the problem? Well, we forgot to do one thing. I forgot that this is an executable, which means it needs a shebang. So let's go ahead inside of our packages CLI source index, and let's copy the shebang which we wrote up here. And then let's go inside of local MCP source index, and let's go ahead and add it at the top. That was the problem. That is the issue. Let's confirm that inside of local MCP package JSON, we didn't forget the bin here, sendkit MCP. Great. So now that we have the shebang, let's go ahead and publish this entire package again. Since we are publishing it again, we have to modify its version. So I'm going to bump this one to 0.1 instead of sendkit MCP package JSON. So make sure that you do the same. So I'm going to go ahead and do run release, and this is pack, and then this is local MCP. Let's go ahead and ensure that's correct. Then let's go inside of our packages, local MCP, and let's go ahead and do publish access public. So once again, let's authenticate, and that will update the package. Once you publish an update, you can see the new version right here, so 0.0.1. Keep in mind that sometimes NPM doesn't really update the version right away. You can see that in here, it still says it's on version 0, so don't worry if that happens. Try and go inside of your organization, and chances are that you're gonna see the updated version number right here. But even if it doesn't appear here, don't worry, here's what you can do right now. Simply go ahead and test the command again. So when we tried running this previously, it threw an error because of the missing shebang. But if we try it right now, it appears to be hanging, which is exactly what we expect, because this is intended to be consumed by agents and not by humans. So even after a successful test, it might still appear as if the MCP is not working. Both in Claude Code and in OpenCode, I can see that there are no MCPs connected. I simply have to assume that this is due to stale cache, so go ahead and change from npx to bunx, which hasn't been cached. And let's go ahead and change that in both mcp.json and opencode.json. So just change this to bunx, which is essentially the equivalent. On Windows, it might be bun and then x. So if bunx doesn't work for you on Windows, try doing this as a separate argument, right? But try this first. I'm not really sure because I don't use Windows, but I did have some users reporting that bunx doesn't work for them out of the box. Either way, it should work with npx. It's just that it's cached on my machine this way, so I have to do something to show that it works. So once I try Claude now, there we go, magically works all of a sudden. SendKit connected, and let's try OpenCode, and hopefully there we go, one successfully connected MCP. So this just shows we've successfully published this and we have fixed the issue by adding a shebang. It's just that npx is still cached on my machine to use the wrong version. Let's go ahead and try it out by sending a message. Use SendKit MCP to send a Telegram message. Provide it with a chat ID and the message hello from Claude Code deployed local MCP. And let's go ahead and do the same in OpenCode. And now let's go ahead and give it the permission here because it needs it. OpenCode, I think, doesn't need permission. So we should now have two messages, and we do. Hello from OpenCode, deployed local MCP, and hello from Claude Code, deployed local MCP. So we have successfully verified that all of the packages we have published so far are properly working and usable to all users who wish to install it on their machines. So we have successfully taken this project from local only to something anyone anywhere can use. Now it's time to create a GitHub repository for this project so that we can actually deploy the remote MCP by simply connecting this GitHub repository to a service like Railway, Vercel, etc. And let's make this repository public so that we can finally create a skill file which can then be distributed by simply pointing to the location of the skill in this public repository. So I'm going to give this repository a name of SendKit. I'm going to choose the visibility to be public, and I'm just going to hit create repository. And since it already exists, we're going to use this option right here and not this one. So it already exists. So first things first, we have to commit all of these changes here. So let's go ahead and do git add, git commit feature, add npm publishing. And once you've committed all of your changes, simply paste those 3 lines we just copied from GitHub down here. And what that's going to do is it's going to synchronize this local repository with this GitHub repository right here. Now that we have the GitHub repository published and all 3 packages published on npm, the only thing left to do besides the skill is to deploy the remote MCP application. There are a few things we have to modify in remote MCP package JSON before we can deploy it. Unfortunately, most cloud service providers do not recognize the monorepo catalog version, which we alias for using the workspace tag. Because of that, we have to specify the actual version that is published on npm. You can find that version by going inside of your packages, core, package JSON. So for me, that's 0.0.0. So I'm gonna go ahead and specify it right here. The second thing we have to do is add a start script, which will very simply be bun run source index.ts. This script is needed so that when you deploy it, there is a start command which is recognized by the service and it's runnable. It will also purposely have bun run at the beginning, so it recognizes the package manager that we are using. Let's quickly test it out by going inside of apps remote MCP, and let's simply do bun run start. And you should see the following message. Once you've done all of that, you can go back to the root and do a git commit. So I'm going to commit very simply here, feature update remote MCP, and let's do a git push. And now that the latest commit in our GitHub repository is this commit in which we've updated the remote MCP, we can safely deploy it. The remote MCP Hono server can be deployed anywhere, since the code we wrote is entirely provider agnostic. That being said, I'm going to be using Railway to deploy my application. And you can do the same using the link on the screen, which will also give you access to $20 in Railway credits. Once you've created your account, go inside of your dashboard and create a brand new project. Choose the GitHub repository option and select SendKit. Because of the way we've structured our monorepo, Railway has recognized that SendKit Remote MCP is the only deployable application. So that is once again the reason why we've separated it into apps folder and we haven't put it within the packages folder, because the apps is a boundary. This is deployed. This has some kind of HTTP transport or protocol. And packages are something that are going to be either used internally or published on NPM. So this isn't just semantics or opinionated folder structure. This is an industry standard so that most cloud providers recognize your monorepo and intelligently extract the remote MCP deployment. Now let's go inside of the settings for this service and let's find a button to change or add a root directory. You can do this on Railway, Vercel, Netlify, and most major providers. Just search for something similar to root directory. And then in here, you will most likely see autocompletes of existing folders within your codebase. And go ahead and choose apps remote MCP. So we want to build and start this application from this specific folder. We don't want to do it from the root because that's just going to mess up all of the catalog workspace versions. So we are purposely isolating this deployment to appear as if it was a standalone application unrelated to this monorepo. That's because we changed the package.json version here to an exact number, semantic version, and not use the catalog workspace tag. So if we were to deploy from the root, that would cause some problems with versions. So because of that, you have to change the root directory here. That should be all you need to do before you deploy. Just make sure that this is preserved, so you can close this, click again in the settings, and make sure you have this root directory. And then let's go ahead and click deploy. Once you have a successful deployment, you can generate a domain by going inside of settings, networking, and click generate domain. And just like that, you will get your custom domain. If it asks you to enter a port, you can put 8080. And now that you have a static and deployed remote MCP URL, you no longer have to use the temporary ngrok URL. You can disconnect that. You can even completely delete it from the list of applications that you have. Go ahead and create a new app, SendKit production, and then go ahead and use the new URL which we just deployed using HTTPS. So you can see this is my production URL on Railway / my environment token for Telegram / MCP and set it to be no auth. Let's go ahead and click create and let's see if it's going to successfully connect. And there we go. Looks like it all works, meaning we have successfully deployed the remote MCP. You can of course do the same thing onto Claude.com. Just make sure to delete your existing SendKit connector because it only allows you to have one custom connector. So let's go ahead and click add custom connector, SendKit production. I'm going to paste that URL with my Telegram environment key / MCP. I'm not going to fill in OAuth client and I'm just going to click add. And there we go, it recognized the tool Telegram, meaning once again, it successfully read the MCP metadata and information, meaning this is completely correctly deployed. At this point, some of you might be confused or your deployment is crashing because we didn't add clerk environment keys. And you might be wondering how come my app doesn't need clerk environment keys, but your app is crashing. And how come when I've connected the deployed remote MCP server to ChatGPT.com, I selected the no auth option, even though we had a whole chapter about adding the OAuth authorization. The reason is very simple. Before I decided to record the chapter on how to add OAuth authorization to our remote MCP server using Clerk, I have already finished the entire tutorial. So that lesson is an extra lesson I've decided to add to this tutorial. So because of that, I didn't include it in the deployment steps. So that is what I'm going to do now. I'm going to show you some slight changes that you need to do so your deployed remote MCP server also has Clerk's OAuth protection. So the only thing you actually have to do is add Clerk publishable key and Clerk secret key inside of the variables section inside of your Railway service. So simply click raw editor and go ahead and paste the environment keys here. That's all you need to do. And after that, hit deploy. Once your app successfully redeploys, you're also gonna have to connect to ChatGPT by selecting the OAuth authentication and of course using your Railway deployment URL in here. Then inside of here, you're gonna need to select user-defined OAuth client. You're gonna copy the callback URL and you're gonna paste it within your Clerk's ChatGPT OAuth. If you need a reminder, I would highly suggest going back to the chapter where I implement OAuth for ChatGPT and Claude. And for Claude, you actually don't need to do anything because Claude can successfully create its own OAuth client, but ChatGPT needs some help, so it's a bit more complicated. Nevertheless, once you add these environment keys, you will have a well-known endpoint which basically instructs clients to where to find OAuth information. Once again, I highly recommend just going back and rewatching my chapter in this tutorial on OAuth configuration for the remote MCP server. Now that we have developed the CLI, the local MCP server, and the remote MCP server, and everything is published and deployed, we are finally ready to create the skill. The first thing I recommend doing is adding the skill creator skill to your agents. So choose this one from Anthropic with almost 260,000 installs. Simply copy this snippet and go ahead and install it. Now inside of our project, let's create a brand new folder called skills. And inside of here, let's create a new folder called SendKit. This folder will be the name of the skill, which is going to be displayed on a registry like skills.sh. So if you're wondering how does this exact name get generated, well, it reads the actual folder where the skill file is put in the GitHub repository. So if we want our name to be SendKit, you need to create a folder SendKit and then inside skill.md file. Next, open Claude Code within your project or any other coding agent which you use, which also has the skill creator skill enabled. And let's tell it to do the following. Modify the skill.md within our skills folder SendKit folder to explain the following. Use SendKit to send Telegram messages from agents through the SendKit MCP tool or CLI fallback. Use this when a user asks to send a Telegram message. Use SendKit, interact with the SendKit toolset, or verify SendKit manually. Or choose between SendKit MCP and CLI workflows. And then let's tell it at the end, use skill creator skill. Good thing about running this command within this code base is that it's actually going to gather context about SendKit in the very code base where it is developed, meaning that it's going to have a deeper understanding of how SendKit works, so it's going to recognize what this actually is. I'm going to go ahead and approve these changes, and then we're going to review the skill file to verify this is what we want. Let's review the output. So skill.md. In here, it uses the standard format for the name and description, which is great. The name is SendKit and the description seems fine. Send Telegram messages from an agent through the SendKit MCP Telegram tool with the SendKit CLI as a fallback. Use when the user asks to send a Telegram message, mentions SendKit, wants to interact with the SendKit toolset, or asks to verify SendKit manually. Great. So in here is a brief description. Now, of course, this might be different for you, but it should generally be similar to this. SendKit sends Telegram messages. It exposes the same operation two ways, both backed by our SendKit core. We have an MCP tool, which is preferred for agents. You can, of course, change this rule. You can go ahead and instruct it, hey, make the CLI the preferred tool and use the MCP as the fallback, right? It depends on how you want your skill to be used, of course. So in here, it will document both the MCP tool and the CLI, which has to be globally installed on the user's machine using the binary SendKit, which in here is documented as the fallback if MCP is unavailable. But again, you can change this if you don't like this behavior. What you should care about right now is that the arguments are correct. So both MCP tool and the CLI take a chat ID and the message and then call the Telegram bot API. Choosing MCP versus CLI, prefer the MCP tool whenever the SendKit MCP server is connected. It needs no shell and the bot token is supplied by the MCP client environment. So this is its reasoning why it prefers MCP over the CLI tool. Depending on what your actual MCP and CLI tool is doing, you might choose to do it the other way around. But this is just one way of doing it, for example. So when should it use the CLI? When MCP server is not connected in this session. This is a great rule because we can immediately test if the skill works or not. What we're going to do in a moment is purposely turn off all of these configuration files for MCP servers, and we're going to see if the skill is then going to use the CLI to perform the same thing. So in here we have the MCP workflow. All of this looks good. The bot token is read from Telegram bot token in the MCP server environment. See MCP JSON. Do not pass it. Okay, I think this is true. True. I don't like how it mentions this. I think it won't cause any problems, but okay. CLI workflow. Perfect. So it even documents how to add the Telegram bot token and where it's going to be stored. Great. The arguments are correct. We have the output, which we know how it's going to look. And this is what I don't like. Run the CLI without installing the published package by using the workspace dev script from the repository root. So this is one problem of running this command within the code base, because it can recognize that we have some dev tooling here. So I'm going to highlight this exact scenario and I'm going to tell it, consider that this skill will be distributed via a public registry. Do not add guides on local development scripts or usage from this code base. Bad example. And then I'm going to paste that. So I just want to clarify, this code base is a great way to understand what SendKit is, and you've perfectly described how MCP and CLI works, but avoid using development only or maintainer only scripts. So I basically want to make sure that this skill is production ready so that users who don't have access to this repository can run it. So since I've highlighted the exact problematic case, I think it will now remove that. Beautiful. There we go. So run the CLI without a global install using bunx SendKit using my organization scope or npx equivalent. Perfect. This is exactly how it's supposed to be used in production here. So I was kind of thinking that this .mcp.json might have also been sneaked in here because it recognized that I have that file. But I think it's just thinking in general how this file will most likely exist if someone sets up the MCP configuration. So I think we can leave this as empty. So feel free to take a look at my source code if yours doesn't look like this and you just want to copy and paste it, but it doesn't need to be the same. You know, all of these skills somewhat look like this. And once you have this skill, go ahead and commit it. So I'm gonna go ahead and do git add, git commit, feature add skill md. And let's go ahead and do git push. Before we test our skill, if you are using Claude Code, make sure to go inside of your connectors and remove SendKit in production entirely. The reason is that Claude Code will actually use the connectors which you have added on the web here. And I would recommend doing the same thing in chatgpt.com. So completely delete these connectors so that you can test Codex and Claude Code without any chance of them using the remote MCPs which we have connected onto the HTTP clients. To properly test whether our skill works or not and to learn how to distribute it and add it, let's make sure that we are not inside of SendKit or whatever is the name of your project. So go anywhere outside. Make sure that Claude Code and OpenCode will not accidentally connect to any MCP servers, because in this codebase we have the MCP JSON and OpenCode JSON. So go somewhere where there is not going to be a single MCP server. So if I go ahead and search for MCP, you can see that I have some Railway and React Grab, which are my global MCP servers, but you shouldn't have any. And inside of OpenCode, if I go here, I have no MCPs. So whatever you see here, just make sure you don't see SendKit anywhere. So this is why we also had to turn it off on Claude.ai, because it will use that remote MCP. So let's just make sure that we are in a situation where we have absolutely no MCP servers. And now if I go ahead and tell it, use SendKit Telegram tool to send a Telegram message. Or here, use SendKit Telegram tool to send a Telegram message. Let's see what is going to happen. As you can see, it doesn't understand what SendKit is because we are no longer within the SendKit repository, right? So it's being confused. It's asking us for clarification. What is this? Is this some kind of command? Is it some kind of API? You can see it is very confused. It doesn't know if this should be an MCP server. What is it? This is the point of a skill file. So you can install it on your machine. It will be added into your coding agents. And wherever you find yourself, it's going to search for some MCP tools, or it is going to fall back to SendKit. And it's going to use this instead, which, as you can see, is available even outside of your code base. That is the point of this skill, which we've just created. So how do we add this skill to Claude Code and OpenCode? Distributing your skill is extremely easy thanks to skills.sh registry. All you have to do is make it publicly available somewhere on GitHub and make sure that the skill.md is placed within a folder which is named exactly how you want this skill named. So go ahead and click on that folder here and copy the URL. And once you've done that, simply go ahead anywhere within your machine, npx skills add, and paste that URL. So this is my URL, SendKit tree main skills SendKit. And let's press enter. As you can see, that has successfully fetched the skill file. So it found the skill. In here you can see a brief description and then just follow the normal installation. So just go ahead and select enter. I would suggest installing it globally so it is available everywhere, and choose a symbolic link so you don't have a bunch of files. Instead, you only have one file. And then let's proceed with the installation. Great. Let me go ahead and open OpenCode once again this time. So if I go inside of my skills and if I search for SendKit, would you look at that? I now have a SendKit skill. Let's go ahead and do Claude Code once again. And there we go. I now have SendKit skill installed. So let's try this again. Use SendKit Telegram tool to send a message. I'm going to immediately provide the chat ID and I'm going to say a message, hello from production ready skill. And let's see what's going to happen. As you can see, it is using the SendKit skill. I didn't even have to tell it to explicitly use that skill because we have correctly described its behavior. And you can see that I didn't even have to have this installed globally on my machine. It simply used bunx to run it one time. And since I did initialize it, I do have the config token stored on my machine. So if I didn't have that config, it would throw an error and tell me that I first need to run CWA-dev SendKit init with the Telegram token. But since we've already done that a few times, you can see that it works. Let's take a look. Hello from production ready skill. Let's go ahead and try it in Claude Code now. So use SendKit tool to send a message, chat ID, and message hello from Claude Code production ready skill. And let's see if the same thing is going to happen. There we go, successfully loaded the SendKit skill. Now it's trying to send it using the MCP tool. So let's see if it will recognize that it doesn't have it. There we go. So you can see the SendKit MCP tool isn't connected. So I will use the CLI fallback and you can see that it's doing the same thing. So I just have to confirm that I want to do this. And there we go. It is successful. Let's take a look. Hello from Claude Code production ready skill. We have successfully distributed our skill and we have installed it globally. So every single agent that we want to use SendKit in is now working, whether or not we have the MCP tool connected. Amazing, amazing job. In this tutorial, you've learned how production-ready MCP tooling and skills actually look like. We've developed this within a monorepository, so we can maintain all of our adapters and our deployed applications along with the actual skill file in one repository. You've learned how to distribute packages to NPM and how to deploy services to Railway. Amazing, amazing job. If you liked this video, remember to leave a like, share, and subscribe, and leave a comment about what else you would like to see me make a tutorial about. Thank you for watching and see you in the next one.